artifacts. That comes under pre-processing. Already we have discussed that. That's why it is written. You see, artifacts may obscure, distort, or completely misrepresent the true underlying recorded signal being observed. And if you look into the diagram, biological artifact, so here you see due to your say muscular artifact, one peak is there, and it is already marked. That is your artifact. Here, this is your another artifact. This portion. So these are due to non-biological artifact. It may be due to motion. So next we'll discuss. This is your background. Why we need to filter out the artifacts before diagnosis. That's why this is its motivation. And let us move to different techniques by which we can remove these artifacts. So before going into that, if you look into this particular slide, some terminology here it is explained. You see, ocular artifacts are most common and influential artifact often dominate over other biological contamination sources like ECG, EMG, as well as non-biological interferences, contaminated signals. And ocular artifact describes a number of contaminating voltage potential caused by eye activity, like your eye movement, blinks, eye fluttering, yield movement, lateral gaze, slow eye movement, and roving eye movement. Different patterns of eye movement comes under ocular artifacts. So next slide, if you look into, you see this is your multi-channel. It shows multi-channel EG signals, and in this red marked region, one eye is your closed, another is your open. When you are opening your eye, that time it interferes with your EG signal. That's why this kind of fluctuation occurs, and it will find this kind of fluctuations, and we have marked it. Next, different your artifact removal techniques. That is our main focus. If you look into your existing literature, two methods are there. First is your avoidance and rejection of your artifact, and second is your identification and suppression. Identification of artifacts or noise and suppression. So one very popular technique is there. If you look into literature, blind source separation, BSS method, worked well since long days to remove ocular artifact. And in recent literature, we will find different your statistical techniques like ICA, CCA, PCA, and MCA. So if you have special interest, you can go through reference 7 and 8. You will find its details. ICA, independent component analysis, principal component analysis, different type of your component decomposition techniques are there. Different kind of your component analysis techniques are there. So these techniques are also being used in recent literatures. So here, what happens, offline, these techniques are offline and manual interventions are required for tuning the parameters. And if you look into the structure of BSS, that is your blind source separation technique. That is your state-of-the-art technique for artifact removal. If you look into any literature, you'll find compression, of any proposed new method has been done with BSS, blind source separation technique. In this technique, you have two main blocks. One is your linear mixing your block, and second is your identification block. In first block, you have one unknown source S and mixing matrix A. If you your multiply S with A, you'll get AS, and in that we are mixing your white noise, so you'll get observed signal X. So observed signal X is combination of AS plus N. X equal to AS plus capital N. So white noise added signal, and afterwards in identification part we are just giving input that X, and in identification part you have unmixed matrix W, and if you multiply W with X, you will find estimated source S dash. So in blind source separation technique, we identify the estimated source. It may be that unknown source may be your different kind of artifact due to your EG, EMG, or any non-biological your noises. So we estimate the source and discard the noise. This is your standard technique. Apart from these, in literature 9 and 10, if you look into from references, you'll find different adaptive filtering technique or regression techniques for removal of artifact. In adaptive filtering technique, that we know you have signal with your different artifacts, and afterwards you have reference EG or ECG signal, EOG or ECG signal. Now, if you update the weights based on your errors, you can get a noise-free signal. This is your conventional, your adaptive signal algorithm. It may be driven by LMS algorithm, least mean square, RLS. So many adaptive algorithm are available in literature, so you can use any of them for filter out the noise. You need to adapt the weights with several iterations, and ultimately you can get the clean EEG. Next, in literature, further literature, it is being observed to scientists using wavelet denoising method for artifact removal. And in that technique, what happens in that technique, some tuning parameters are there that need to be chosen, and like your what kind of mother wavelet you are going to use for decomposition of your noisy signal or artifact added signal. Choice of your thresholds you need to tune such that noise can be eliminated properly, and how many decomposition level you are going to use for better denoising purpose. So these things, these kind of settings need to be tuned if you change the signal database. Suppose a particular wavelet setup, wavelet based denoising setup is working fine with some database, and when you are changing your EEG database, that time it may happen that same setting would not work. You need to tune these parameters, like you may change your mother wavelet, you need to change your decomposition level, and a choice of thresholding technique. It may be hard threshold or a soft threshold. Even thresholding your coefficient you need to tune. So that is the means manual intervention is required. It is not completely your automatic. If you're changing the database, you need to tune this parameter. That is the challenge in this wavelet based techniques. Otherwise, wavelet based technique, denoising techniques gives very good result, but it requires some manual in the tuning or intervention. It is semi-automatic, you can say. Now, if you look into the block diagram of waveform wavelet based your denoising technique, contaminated EG input signals are given as input. Next, you have wavelet based signal decomposition technique. You have to use wavelet tool. You have to select the mother wavelet. You have to select the decomposition level. You have to choose the threshold coefficients, and you can decompose the signal, and afterwards you have to remove the unwanted part coefficients, and afterwards you have to again do the inverse process, that is inverse wavelet based signal reconstruction, and after then you will get your artifact free EEG signal. So the person who deal with your signal processing are well familiar with your wavelet based decomposition, your technique for EEG artifact removal. Next, here our emphasis would be on empirical techniques, empirical mode decomposition technique, and some advancements are there. Ensemble empirical mode decomposition techniques. So here, if you look into your third block diagram, in recent some publication in 2022, some modifications are there with EMD, that is called your modified EMD techniques. Authors has been used for removal of your this kind of EEG artifacts, mainly your it may be motion artifact, it may be your ocular artifact based on your EMD. So at input you have contaminated EEG input signal. Next you are just decomposing that contaminated signal in terms of IMFs, intrinsic mode functions. If you are familiar with EMD, we decompose our signal in terms of your multiple IMFs, intrinsic mode functions, and afterwards what we do manually, we just set threshold based on some statistical parameters, and afterwards we just remove unwanted IMFs, intrinsic mode functions, and we put your inverse empirical mode reconstruction, and through that we recombine all IMFs, remaining IMFs, and we get the artifact free EEG signal. And if you make this your thresholding technique automatic, then this method becomes your automatic. No need to do any your manual intervention into that. So how to automate that process means threshold setting of threshold should be data driven based on some statistical parameters, and by introducing some optimization techniques, with the help of some optimization techniques, you can set your threshold values, and no manual intervention is required. Means how much IMFs you need to decompose the signal into how much IMFs. So that should be your data driven and automatic with the help of some automated algorithm. Then no manual intervention is required, and whatever outcome we'll get, that is also having your very good signal to noise ratio, And if you look into further literature, so then you'll find कि in ocular artifact domain, reference channel is required. In some techniques it is not. In some technique it is adaptive filters are used. In 2007, 2012, 2006, 2019, even 2020 also some papers are coming in adaptive filter domain by using different variants of your adaptive filters. Your epilepsy disease database has been used, taken up over here, and artifact has been removed using adaptive filter techniques. Different time frequency analysis techniques has been used for the same for schizophrenia, one mental disorder kind of disease. In that also means in that schizophrenia database, artifact removal has been done using time frequency based techniques. So all these diseases like epilepsy, schizophrenia, it may be neural disease or a mental disease. So those disease can be detected with the help of study of EEG signal. That's why artifact removal is very much vital. And this data recording is very much lengthy. That's why it requires you a lot of computation power and analysis. Analysis. Now you see in some other techniques here, people have used independent component analysis, ICA, for sleep study, sleep study purpose also. Sleep disturbance are there. So in that, that is also one of the prime disease. So using EEG patterns, the diagnosis of sleep-related your disease can be done. Next, different cognitive tasks can be also you're captured with the help of EEG. So in that also artifact removal is required. And here you see here principal component analysis technique has been used in 2017 paper. So 3-4 papers are there in this domain. So many papers are there. So here we have taken your 2-3 paper. Here some limitations are there in PCA technique. It fails when signals are of comparable amplitude. Method needs some prior information to detect PCA as the artifact. So some limitations are there in your existing techniques. So if you move forward, wavelet based technique also you see the limitation. Setting of threshold, selection of mother wavelet, manual setting of level of decomposition. These are the some drawbacks. And existing EMD technique also some limitations are also there. Though it is giving you good results. Like EMD method has limitation of mode mixing, lack of theoretical background and iterative run. It suffers with high computation and longer process time. Processing time is your high for the case of empirical mode decomposition. That is one drawback. So modified EMD can solve the purpose. Now next, let us move to your motion artifact removal technique. This is your not biological in nature. So here it can be done in motion artifact can be due to your head movement, body movement, jaw, or your movement, walking, running, sleeping, talking, working on PC, watching TV, or many more examples are there. So during this activity, if a patient having your EEG and data is being recorded continuously, so during that process, this kind of your motion artifact introduced in the channels, different channels, and for proper diagnosis, you're in pre-processing stage, this kind of your uh, artifact elimination is very much your essential. So, what is the problem with this kind of motion artifacts? It increases false alarm in case of medical emergency. False alarm. Suppose due to this kind of your motion artifact, its amplitude increases, and it seems some alarming sign, but it is actually not. It is because of this kind of artifact. So it is mentioned it increase false alarm in case of medical emergency. False alarm. It is giving you wrong data, misleading in detection of prominent patterns present in EEG signal. That is another important thing. And third thing is your deteriorate BCI system performance during practical applications, brain computer interface applications. We use EEG signal, so in that also its performance degrade in presence of your this kind of artifacts. So there's a so many reason or motivation point for work in this area for elimination of motion artifacts. Now in existing literature, if you look into, you'll find your wavelet based techniques. Next, you will find your different techniques like your multi-resolution total variation. MTV technique is also there, and adaptive filtering techniques are also there. Ensemble empirical mode decomposition with CCA hybrid techniques are also there. So if you look into the performance, 68%, 68.56%, that way, 52.2%, that kind of accuracy are there. Means, so there is a need of research, focused research in this domain, such that your more important your technique can be developed to solve this purpose. So this is one, based on literature review, this framework has been introduced. You see type of artifacts. This is your brainwave EEG, and different artifacts are introduced in that in different channels in raw EEG. Now, those things may be ocular, muscular, cardiac, sweat, or other kinetic artifacts, or it may be your motion or other instrumental artifacts. Next, if you look into the literature, two type of techniques are there. One for removing your artifacts. One category is homogeneous method. One category is homogeneous method, and second category is your hybrid method. So under homogeneous method, you have different regression techniques, filtering techniques, wavelet based technique, or blind source separation based techniques, and some statistical more other techniques are there, like your independent components analysis, your principal component analysis, CCA, MCA. So many techniques are there literature, and EMD also, empirical mode decomposition. Now some new trends are there. If you use your another category, that is your hybrid method. You have existing methods, you can combine your existing methods to make it hybrid and test whether this method is working fine or not in this domain. So first technique like your BSS plus WT, blind source separation and wavelet transform. If you use this, first pass your signal to BSS block, and you suppose got you removed artifact up to certain extent, and next again after passing through what BSS, whatever output you are getting, you give input to your second block, like your WT, wavelet transform, and you will get your final output. That way hybrid technique works. Means you have to pass the signal through both the blocks and you will get the final outcome. Now, nowadays machine learning technique is being also introduced in this for removal of your artifacts, like your blind source separation technique you have used, and We have tried to eliminate artifact, and it is not 100% success. Next, we are introducing your different machine learning technique for removal of your this kind of artifact. So in some studies, we found CNN based 1D CNN based filtering method, machine learning methods they have used for filter out the noise, and it is giving you a good performance. Now, third stage, suppose you got the result, and then how will verify you got the correct data or not? So for validation purpose, you need some evaluation parameters. Those are signal to artifact ratio. In this domain, generally these are the parameters. On the basis of this parameter, we evaluate the performance of this method, whether this method working fine or not. Those parameters are signal to artifact ratio, peak signal to noise ratio, difference in SNR, power spectral density, distortion. Now, error related mean square error, root mean square error, normalized mean square error, mean absolute error, and relative error. And in last category, you have signal information related evaluation. Those are correlation coefficient, mutual information, coherence. These things are there. So these definitions you will easily get if you explore. Just simply Google it. You'll get the code, event code, and formula for that. These are the standard your evaluation parameter for for the technique. Whether your technique is your good or bad or performing well or not, you can analyze. For validation purpose, we need to analyze these things. Now, where it is being used after cleaning these things, it is used for clinical diagnosis, for brain computer interface, like kind of your applications, and application specific feedback for that also. So you use this. Next, your research gap. The research gap is mainly if you look into this artifact, it covers a broad range of frequency. The broad frequency range of artifact may vary from very low, that is your motion artifact, to high frequency, that is your artifact due to residual charge. So you see, artifacts using single small filter or single technique, it is very difficult to remove all kind of artifacts using single technique. That is a challenge. Suppose you have designed one adaptive filter, since your dynamic range of frequencies is very wide, so it is very difficult to remove all kind of artifacts using a single technique. That is the main challenge. Suppose one technique is working fine for motion artifact, and the same technique would not work. It may happen it would not working fine for your ocular artifact. So you have our challenge is to devise a technique which gives better performance for all the artifacts. Or some hybrid technique which can eliminate, if you pass the signal with multiple your blocks, and ultimately your signal would be your fine, means it can be artifact free. Relatively, its performance would be good. And second challenge is that in biomedical signal, you can't abruptly cut any part of signal. Each and every part of signal contains very valuable your information. So during elimination also, you have to think over whether important it contains any important part or not. So the engineers or biomedical engineer cannot, or computer scientists can't work single-handedly. We have to join hands with the doctors to such that we can get real feedback, and afterwards your technique can be validated, and we can say ki this technique is working fine. From our end, suppose our parameters are looking fine, but from doctor we should take the feedback of doctors. So in this work, this kind of works, always you have to keep one specialist from medical background. You have to collaborate such kind of medical background people in your research, so that your outcome should be realistic one. It should be useful for the society, not simply your we are playing with the signal and getting some result. Means we should some we need some valuable feedback from medical persons also. Now, if you look into this kind of research, here the main motivation is your suppression of those signals. It may be using hybrid signal processing technique, different signal processing technique you can use, or machine learning based techniques or deep learning based techniques people are using nowadays. And pattern nowadays that kind of trends are there. Now, what kind of database? You can take a snapshot of this particular slide. In our research, in our lab, we use this database from DOI are also given. Here you can request the data for research purpose and get it. You can get Temple University artifact corpus here. From this particular your repository, you can get variety of data related to EG, and it is quite useful for basic research. And BCI competition for database set 2, that is also openly available. Motion artifact related one data set that is recently open for researchers. So these are the database. Suppose any researcher having your interest to work in this domain, EEG artifact elimination or EEG related any kind of your application development, so you can use this database for this purpose. And apart from this, suppose you want to work in new domain of EEG, so you need to collaborate with some hospitals such that you can get the real-time data, raw EEG data as per your requirement. Now, one of my student has worked this, proposed this algorithm. This algorithm is based on motion artifact suppression from EEG signal, and it is working fine. This algorithm is based on modified your EMD, empirical mode decomposition technique, and one modified LOG filter has been also introduced for removal of your artifacts. So if you look into this block diagram, you have noisy EEG signal. We have decomposed this noisy EEG signal into IMFs, intrinsic mode functions. So it's having two parts. One is your the signal having your high frequency component, and another is your signal having low frequency components. So 1 to k by 2 IMFs are there, and remaining k by 2 plus 1 to k your IMFs are in second side. So suppose motion artifact analysis, we know the motion artifact lies in the low frequency region. So what we have done, we have used one LOG filter over here, and we have eliminated your those artifact part using your this LOG, and afterwards here also we have used some automated technique for selecting the IMFs, how many IMF we should take. We have automated this technique using one algorithm, and afterwards again we have automated the tuning process of LOG based on some your objective function, and that objective function contains different signal statistic parameter like your standard deviation and power spectral density kind of thing. And afterwards after getting the signal from LOG filter, we have added high frequency component with the artifact free part, and we have reconstructed the signal, denoised EG signal, and again we have compared this signal with the actual noisy signal, and we have calculated the references. We have compared with reference signal with this signal, and we have evaluated different performance like your SNR, RRMSE, correlation, PSD, PSNR, different values, and compared with other techniques. So from this block diagram, it is not so clear. So let us have a pictorial view of the signal, then things will be quite clear. So if you look into this part, this is your all electrode placed. You have one reference channel, you have some noisy channel. So here what we have done, we have not taken all channels data, we have taken FP1 channel data for processing or testing the efficacy of this technique, modified EMD technique, noisy channel FP1, and from that we have extracted 1 minute your data, time series data, block by block we have processed. So extracted 1 minute your data. Afterwards we have done your baseline correction. Next part is your pre-processing is your baseline correction. We have done that. So baseline correction is your very fundamental technique. It is being done in all 1D signal processing, your pre-processing stage, processing techniques in pre-processing stage. Like your, if you work with your speech signal, geophysical vibration signal, or other your audio 1D signals, so everywhere you'll find your baseline correction. So we have done that, and its method, if you look into, simply you have to Google, you will get whole method if you have special interest in that, and you will get code also for baseline correction. It is very simple technique. We find the mean and just subtract with the signal. Next, you amplitude normalization, we do amplitude normalization afterwards. And next, you see, we have taken the signals in different state of the signals from different cognitive your actions, like your standing position signal, walking position signal, walk plus brain computer interface tasks is doing that kind of signal, and so the of different durations. This particular database contains your that kind of signal. Here we have used two databases for validating our algorithm. So if you look into, you have noisy signal, done baseline correction, and afterwards amplitude normalization, After doing also, we got your say signal of your 2 minutes in standing position like this. It shows like this. Walking position it show like this, and walking plus BCI it's looking like this. Afterwards, if you look into the output of modified DMD Laplacian of Gaussian filter algorithm, this is a hybrid algorithm we have used. So we have decomposed the signal into your 10 IMF your function, intrinsic mode functions. If you go through the basic of EMD, you will find we decompose the signal EMD through EMD into different IMFs in intrinsic mode functions. So if you look into first IMF, its frequency is quite high. Second IMF, third IMF, that way we are moving to up to 10th IMF, so it is very low frequency. So that's why what we have done, we have segregated this whole IMF into two categories, 1 to 5 in one category. We have not disturbed that part because motion artifact does not contain in that part. Motion artifact lies within your low frequency part. So we have taken the next part, IMF 6 to 10, and we have passed this thing with the through LOG, modified LOG filter, and after filtering, we have combined that filtered signal with the these IMFs, high frequency IMFs, and we have reconstructed the your EEG signal. So if you look into your comparison part, noisy ECG shows red color. Noisy EEG. Noisy EEG is your red color. It shows red with red color. Reference EEG shows with your blue color, and denoised EEG after passing through this algorithm is your this black color. So you see here in this process, this kind of your motion artifacts are there. That's why its amplitude is abruptly changed. That is generated by your red color, and after elimination, it's you see amplitude in black color. It is quite low, and this is your original tends to your original EEG signal. It contains your very important your diagnostic biomarker. It does not lose the diagnostic biomarkers, and you see it removes the noise artifact portion. Now in spectrum, if you time frequency analysis view, if you look into denoise signal, it look like this. It look like this, and afterwards PSD, power spectral density plot, if you do, and that also look like this. You see artifacts added signal having more power because it contains your noise signal as well, and afterwards you have reference EEG, and this is your denoised. Black one is your denoised EEG. Black one is your contains denoised EEG. So this is your pictorial view of the process of this algorithm, how artifact added signal has been decomposed using modified EMD and LOG, your hybrid algorithm, and it is being reconstructed, which is artifact free, motion artifact free. Now, if you look into the again your we have tested same algorithm with the different second database. having different cognitive functions like your standing, walking plus BCI task. You see the performance. If you look into the performance of this, you see your black color represents your filtered EG and white color represents your noisy EG signals. Noisy EG signals. And if you look into time frequency, your spectrogram, time frequency analysis plot, so here also you'll find your denoise signal contains your denoise signal having your this kind of pattern, uniform pattern, and power spectral density plot. If you look into red color denotes your noisy EG and black color represents your denoised EG. Now this is your repetition. So ocular artifact. Earlier we were discussing about your motion artifact. This is your related to ocular artifact. So this is your one of the standard framework. A researcher can use any combination of hybrid method or even think of introducing new method and do experimentation such that they can propose a new technique which is more which gives your very good results with respect to existing. And our main challenge is the technique which can address all kind of artifacts, that is your main challenge. Suppose one technique is working fine with your motion, that is not working for ocular. So main challenge is to devise a technique which can address all kind of artifact suppression. You see, for this work, EEG signal is substitutable. We can conclude like this: EEG signal is substitutable to distinctive biological or environmental artifacts. Artifact correction is one of the severe problems encountered in biomedical signal processing. And in recent studies, we have seen researchers are more focused in hybrid techniques rather than conventional method. And if you look into the proposed method, modified DMT and LOG hybrid technique, it gives your better result with respect to state-of-the-art EEG, state-of-the-art artifact removal technique. Now, before going to the next part, your denoising of EEG signal using machine learning, if any participants having any question, they can ask regarding your first part, that is your motion artifact or ocular artifact removal using your hybrid techniques. So if you have any question, we can interact. Otherwise, we'll move to your next part, that is your denoising of EG signal using machine learning techniques. Any question from any participants regarding the part we have covered till now?
Hello, sir.
Yes, please.
Sir, how wavelet denoising is used for removal of ATAL?
Yes, fine. You see, if you look into your literature, you will find a lot of literature, research papers, where your people have used, researcher have used wavelet techniques for removal of EG artifacts. So in that, what is the key thing? First, you have to take your say 1 minute your EEG sample time series data in some matrix, and afterwards you have to apply one wavelet method, like you can use DB7, DB2, or it may be other wavelet, mother wavelet. You have to select that. Next, you have to decompose that wavelet, your signal with that wavelet into different levels. First, say you have decomposed your signal into 2 level, 4 level, 6 level. That way, you just decompose and see the results, how it's coming. And say, for example, you have taken your 4 level. It's having some mathematical background, means up to what extent you should take. Some formulations are there. Suppose you don't have background of that, so you just use trial and error method. Suppose we have selected 4 level of decomposition. Afterwards, if you look into its plot, you'll find that some coefficients are responsible for your noise, some low frequency components. So in wavelet, what it does, it passes the signal through one set of low pass and high pass filter, and afterwards again it after getting your sound, say some low pass filter output, it is again passes through one set of low pass and high pass filter having your different cutoff frequencies. So that way we just break that signal into different frequency bands, and we visualize the signal in different frequency bands, and we eliminate the noise where it is present. Suppose it is motion artifact, so it lies within low frequency band. So you just remove the coefficient of your low frequency band and apply inverse wavelet transform and reconstruct the signal. So automatically your after inverse wavelet transformation, you will get your noise free or artifact free EEG. And during your this truncation elimination, you have to use your either hard threshold or soft threshold technique. So you can use MATLAB toolbox or Python toolbox as per your availability. So ready-made toolbox are there. You can use those toolbox for using your wavelet transformation, and or you can write your own code in any scripting language which supports it. That is the process. Now, any other question?
Yes, thank you, sir.
Otherwise, we'll move forward. Okay. So you see, if you any researcher having interest to work in this domain, lot of opportunities are there, and it's having your large spectrum of your journals which publishes this kind of research. all biomedical, all signal processing, and all medical journals publish this kind of work since it's having your both the aspects, your engineering and medical both. So a spectrum of journals, it's having your dynamics range is your quite high. Means many it publishes this kind of work published by different journals. So now, denoising of EG using machine learning. So these are the repetition your earlier thing, basics of EEG. So I would not go into that. And signal strength amplitude lies within 10 microvolt to 100 microvolt, not millivolt. It is your microvolt. Amplitude of EEG signal comes around this. If you measure it, it comes around your 10 microvolt to 100 microvolt, and frequency range lies within 0.01 hertz to 100 hertz. So this is your main our field of interest of frequency of related to EEG signal. It is your low frequency. Mainly, main important information lies within the your low frequency. Now, these bands already we have discussed. These are the electrode we have discussed. Now this is your example of multi-channel EEG signal, that is also we have discussed. Now some important your database information they have used. If you look into any database, so you'll find different your signal patterns, like your here in 29 signals are there. In that 19 male data, 10 female data are there. 8 age category of those patients are also given over there. Mean value 20 years. So that kind of information you will get. In addition, you'll find one important information, that is your sampling frequency. You need to know the sampling frequency used during recording, because when you are using any, you say you want to apply Fourier transform to find the frequency range. So that time you need to know your sampling frequency. Otherwise, you can't get the exact frequency present in the signal through Fourier transform. So when you are taking any database, one README file would be there with that. So you need to download that README file. It contains your sampling frequency. You need to note down that sampling frequency. It would be useful in programming part. Now, in addition, other important parameters are your what is the challenge, how many channel are there in that database. That is another aspect. Next, your how much duration you will take for your research. Suppose you have your 1 hour data, so you can't process 1 hour data at a glance. So you need to
emotive epoch period.
So you cannot use we were here. You can't use 1 hour data at a glance. So you need to break that lengthy signal into some blocks. So you can use your say 5 millisecond data, or say 1 minute data at a time, and block by block you can process the whole data. You can pass through your algorithm to get the desired result. If you look into machine learning techniques for used for the particular purpose, like your in literature you will find your support vector machine, classifier has been used, or eye movement based extraction work. And if you look into your in this work, they have used different type of your features. If you look into support vector machine learning algorithm, it is your feature based. So in deep learning, no, that kind of features are required. It takes its feature automatically. So here in SVM, these kind of features they have used in this table. Its mathematical descriptions are given and feature names are there. So these are based on mainly your amplitude based. It may be your different statistical based. It may be some power based. If you look into all the your features in conventional machine learning techniques, if you will find your all features are based on mainly either power based or some statistical parameters like your variance, kurtosis, skewness kind of things would be there, or it may be amplitude based or frequency, some variants would be there. So here it is true for here also. And these are feature based techniques. Next, in some of the works, your ICA components are also used as is ICA decomposition coefficients are also used for training the network, machine learning network. So nowadays everybody having your basic idea of machine learning. It's having two phases. One is your you have to develop one model based on data. It is data driven. That is your training part. You have to train one model based on data, and you have to second part is your test model. So training would be done based on some inputs. Those inputs are nothing but your features, and it's having some target. You have to set some target value, and after training you have to test with some test data. That is your normal practice, and here also that kind of thing has been done. So here instead of using your conventional your power based or statistical features, in some papers they have used different your ICA decomposition coefficients or wavelet decomposition coefficients as a feature also. Next, these are some examples of your ocular artifact, how it look like. If you simulate, if you plot, you'll find this is your 14 channel your EG signal, and eye close or opening kind of movement are there, and due to that you see this kind of red color marked region having some notch kind of thing. This is called your artifact. So this kind of artifact need to be removed to machine learning techniques. This is your border view. We have taken 4 signals only, 4 channels, and this is your, if you look into your noise free, this is your detect eye movement. Eye movement has been done over here. Due to eye movement, fluctuations are there over here at near about 4.5 your second. Now these are the, you see, different type of your statistical parameter. Now next, this is your reconstructed EG using your elimination method. Here you see at 4.5 those kind of artifacts are not there. Some result comparison has been done with your proposed method, with your unsupervised approach or ICA approach, with your machine learning approach. Some improvements are there in parameters. Let us move to from SBM. Let us move to some CNN based technique. Here, this is your 1D RES CNN model. Here, whatever EG signals are there, we have divided that EG signal into blocks and we have processed. And in this particular CNN model, 1D RES CNN model, you have your m number of layers of different filters, and it is being finally your different convolution layers are there, m number of convolutional layers are there, and that details has been given in the next your figure, this figure. If you look into 1D RES CNN network structure, it contains your 3 RES blocks connected in this fashion. You see, this represents the residual block of the convolutional kernel of 3 into 1, 5 into 1, and 7 to 1 your dimension respectively. And 3 residual blocks are connected in series twice, and finally the output of the 3 multi-scale residual blocks are merged. You see, 3 output has been merged this way, and through a convolutional layer, and final reconstruction signal is obtained across output. So if you look into any this kind of CNN networks, different your convolutional layers are there, and different filters has been defined in between, different combination has been taken, and you have to try with your different combinations with some mathematical reasoning, and you will get your success to develop one your this kind of CNN based or deep learning based your method for artifact removal as well. In this is your more detail. You'll find this literature in IEEE papers. We have tested some of the networks and it's working fine. This is your block diagram representation how your CNN blocks has been concatenated. 3 blocks has been concatenated, and finally you are getting the output. So very few works are there in this domain. CNN 1D based CNN model they have used for artifact removal. There's a scope for modification also in this domain. So if you use MATLAB or other Python tools, you will get your these models interface to devise these models easily. You can use the help file, documentation file to reconstruct the this kind of your networks for your application. Now, it is your what's happening in this CNN based model. We are not defining any features. It is extracting its feature is its own in training phase. Suppose you have clean EG samples as a reference, and you have noise EG training samples, and it's finding means by error, and that becomes a feature for it. Feature is your extracted and given for training in 1D RES CNN your model. And during validation phase, we are taking noisy EEG testing sample. Feature is your extracted using same technique, and afterwards it denoises your 1D CNN with the help of 1D CNN model through different iterations of your convolutions using different filters combinations, and finally we are getting the outputs. So this is your basics of your using your this kind of machine learning or deep learning network for your artifact removal. So this kind of trends are there. This is recent trend. So researchers are using this trend to remove. It requires your more resources, computation power to train the model. Otherwise, it's giving your better accuracy, and it can also address multiple artifacts with the same model if you train the model properly. Now, you see, if you process the thing block wise, you can't process complete signal at a time. You need to break the whole signal into some windows, and under that window some part would be very noisy, some part would be relatively less noisy. So you have to identify the noisy part, and you have to pass it through that kind of artifact removal your network and process it. Here if you look into window, some of the window having window 1, window 3, window 5, window 7 and 9 having your some noise element. Having, that means your artifacts having your some amplitude, like your this is your artifact, this 5, this part is your artifact. 6 don't have any artifact. In Windows 6, this is your natural EEG signal, brainwave signals. So Windows 6 do not have any artifacts. 7 having your some artifacts. So you have to eliminate some of the part. You have to identify the block where these kind of fluctuations are there. You have to identify that particular window, and you have to eliminate a remaining part. No need to pass through. It is already okay, and that way means we can preserve the biomarker. Otherwise, if you pass whole signal through that, it may damage some important biomarker as well. So you have to identify which block need to be passed through that kind of artifact elimination filters. Now, if you look into the algorithm in depth, 1D RESCNN, it looks very simple, but inside it's having some algorithm running inside. So in normalize the noisy ECG, it use normalization technique. This the formula is given in equation number 4 over here, where mu is the mean of sample and sigma is the standard deviation of all sample data, and I is the number of sample number. So here what we do, we construct a one-dimensional convolutional neural network. Next we train the network and minimize the loss function of equation, and afterwards ECG test data set is used for testing purpose, and we get the output. Here we use traditional mean square error method to train 1D RESCNN by small batch gradient descent method, and minimize the loss function by Adam automation method. So here you see, since we are not giving any feature input, it's taking its own automatically that feature mean square error as input, and here for training what we are using, gradient descent method using over here. N is number of training samples. This is equation number 6. and loss function is used to train the parameter. Now, after doing so, you'll get this performance graph. After DNN method, this red graph is coming, and noisy signal is this black one. Next, if you look into your time frequency analysis, in that you'll find clean your last graph is giving your age, gives you the clean EEG. It contains more red or yellow part is there. And here in first one, A contains your noisy EEG. So it contains lot of your blue kind of thing. Noises are there. Low frequency, your artifacts are there. And that is being removed. And after that, in frequency domain, you will find it contains your high frequency part, more high frequency part. Here, some EMG, electromyogram signal is added with the EEG. That EMG artifacts is added with EEG, and it is passed through 1D RES CNN model. And after removing noise, you are getting red signal that is your artifact free. Earlier, these dotted blacks are nothing but these peaks are nothing but artifact of EMG, electromyogram, that is due to hand movement or different type of your movement of your muscles produced due to your movement of your muscles, and it is contaminated with your EEG. So next we'll move to EOG signal is added with your EEG, and red graph gives you the artifact free signal. Next, data sets we have used. In this, you see in some where it is 23 active electrodes is being used and 20% data. In different SNR, you see. Afterwards, in different database, information has been given over here. And these are the some results. Red one is your RLS filter method has been used. Different techniques, wavelet based method is used with artifact, your removal technique. And afterwards, we have done some comparison. In that, you see, using your proposed method, that means your deep learning CNN based 1D CNN based method is giving your better signal to noise ratio. This yellow color line gives better SNR ratio with comparison to other your methods. Even with respect to your DNN, this CNN method is also giving your better result. ICA method, RLS filter method, different methods performance has been compared. And you see, this is your EMG artifact. In that case also proposed 1D method is working fine. And here you see EOG artifact has been added and passed through 1D CNN model, and whatever output you got, plotted signal to noise ratio. And here also we are getting better performance. These are overall your statistics. These are the numerical value in different your SNRs, or it may be EMG artifact for the case of different artifacts. These results EOG artifacts. These results numerical term. In terms of numerical terms we have given. Final conclusion, CNN has been local feature expression ability and can better utilize the correlation between EEG signal and noise signal. EEG denoising method based on deep one-dimensional residual convolution network is proposed, and deep convolution network is used to establish a regression model to express the complex nonlinear relationship between noisy EEG signal and pure EEG signals. Next, your convolutional network filter residual data, use large data sets to improve signal denoising and help capture the main feature of EEG signal. Last one, achieve a smaller mean square error and better signal to noise ratio on the test set, and has been noise suppress ability than other better noise suppression ability than other denoising methods. So it is better with respect to your conventional SBM, IC, or DW2 techniques. So these are the some your conclusions, and these conclusions are very vital conclusion. Why CNN? CNN has better local feature expression ability and can better utilize the correlation between EEG signal and denoising noise signal. That's why it's performing better. So these are the main conclusion with your CNN techniques. So I think we have covered your some of the techniques, artifact removal techniques, based on your maybe it may be your some statistical technique, it may be some machine learning techniques or other hybrid techniques by which we can remove the artifacts. So still focused research required to develop a universal method by which we can address multiple artifacts. It may be biological or external. So with this, I would like to today's session. Now it's question. If participants having any question, though they are free to ask. Please, any question?
Hello, sir.
Yes, please.
Sir, I want to ask that mathematically how the intrinsic mode function, that is IMF, is generated or any type of EEG signal.
So mathematically, you see, this is your EMD technique. That is your well-known techniques. Okay. So and tools are also available. So you can easily get that your techniques in literature and in terms of your code. Basically, what happens in wavelet technique? What we do? We pass it through different your bands of filter. So that's why we decompose your main signal into your different band of wavelet coefficients. So here also we decompose it in terms of some intrinsic function. The intrinsic functions are nothing but we pass through the signal through different band. Means we mathematically, physically, it happens like that. IMFs like your IMF one. IMF one contains your high frequency. IMF2 it is relatively less contains less high frequency. That way, if you break the signal into higher order of your IMFs, so you will find your very your low frequency signals, high to low frequency signals, and mathematical all deductions are available. We don't have much scope to discuss that part. You can download any literature. You will find your that is very old technique, EMD. Mathematics are available. Any question?
Yes, sir. Thank you, sir.
Dear participants, if have you any queries, please ask. Okay, sir, I think there is no queries. regarding this or doubts? Everything is fine.
Okay, thank you, Dr. Mandal, and for giving me the opportunity to interact with the participants and inviting me in this FDP for delivering the talk.
Thank you, sir, for your presence, sir. It's our pleasure, sir. You are joining with us and sharing your valuable knowledge on the topic of techniques for the artifact animation or biomedical signals. And thank you, sir, very much. I think by using your knowledge and on this research, we and our participants should be benefited, and they can start their research work. Those who are beginner. Thank you, sir. Thank you very much.
Okay, thank you.
Sir,
Okay.
kindly share the PPT so that we will refer it.
Okay, sure. I'll share. I'll send to the coordinator.
Okay, sir.
Okay.
Thank you, sir.
Okay.
Okay, sir. Thank you, sir.
Okay. Thank you.
Once again, good morning to all of the participants and our respected expert for the next session. So now we should start our second session. Now, our expert, Professor Swanimar Muzumdar, already he's joined. So, sir, please turn on your camera, sir. Sir, am I audible, sir?
Yes, am I audible?
Yes, sir, audible. But I am not seeing, sir. You.
Okay, just a minute.
Okay.
Yeah, good morning.
Good morning, sir.
Good morning.
Good morning. Okay, ma'am. Are you ready, ma'am?
Yes, sir.
Okay.
Yes, sir.
Please start.
Now, I would like to welcome Dr. Swanibhar Majumdar, Professor and HOD, IT Tripura University, and who would talk to Introduction to Artificial Intelligence and ML. Professor Swanibhar Majumdar has more than 15 years of teaching experience. He has completed his BTech from NERIST, then under the Northeastern Hill University, Shillong, MTech from University of Kolkata, and PhD from Jadavpur University. Initially, he started off as an assistant professor, Department of ECE, NERIST, Arunachal Pradesh in 2006. He joined as an associate professor in 2017 in Department of IT, Tripura University. Since 2020, he is working as professor in the same Department of IT in Tripura University. He has been heading the department since 2018 to till date. He has more than 60 publications in various international journals, conferences, books, and book chapters. He has till date guided 5 PhDs from Department of CSE, ECE, IT, and presently 6 candidates are registered under him in Departments of IT, Tripura University. His area of specialization is biomedical signal and image processing, NLP, and soft computing. Over to you, sir.
Thank you, madam, and thank you, Kallan sir. So, without further say delay, I would start off. Is it okay if I shut the video down? Because then maybe network. Okay. So I'm sharing my screen. Let me know if it is visible.
This particular URL is the URL to I have selected.
So is it visible?
Yes, sir.
Okay. So good afternoon to all of you. And before the lunch, I think I'll be the one who is will be stopping you before going to lunch. So thank you to my ex-colleague Dr. Dinamani Singh sir and Kalyan Mandal sir for inviting me here. And this is the second time I'm giving a lecture in NIT Manipur. And last time I was discussing regarding signal processing. So many of you, if you have been in my previous lecture, you have been. I think you have known me. And in this ATAL FDP on recent trends in research development of electronics and communication research area. I'll be discussing mainly an introduction to AI and ML, and as in the second half we have Professor Bhuya. He'll be focusing on computer vision more. So I'll be covering mainly the basics, and in between, feel free to stop me. I may not be completing the whole set of slides that I have prepared, so feel free to stop me anywhere. I'll be starting with the basics. So, starting with this is my story with neural networks. So, this is the first paper which two of my UG students, Dipya Pratim Datta and Samrat Dev Chaudhary, they had completed their BTech in 2008. And in 2009, we had published this conference paper. They were one of them is presently working in ISRO Trivandrum, and the other is working in VECC. That is the variable electron cyclotron. It is under BARC in Kolkata. So they had worked on because I was teaching them neural networks, and they proposed, sir, you have done your some work in image compression, so can we use neural networks for image compression? So I said, I don't know, let's try, let's give it a try. Before that, we were just not studying neural networks theoretically only. We had not applied them in any programming or any other things. And at that time, we started off with MATLAB. But nowadays, most of you who are working in this area know that Python is more full-fledged in this particular case. So starting off with this, this presently has around 19 citation. It is a conference paper, IEEE conference paper, so not much citation. So going ahead, this will be my overview of the talk. I'll be introducing in general to AI, machine learning, and deep learning. And then I'll be going one by one to the artificial intelligence, machine learning, deep learning. And if possible, I'll be giving an overview of neuromorphic computing. If some of you are from the hardware point of view, presently we are mainly having these in softwares, but people are trying to get it in hardware. So if we have time, I can go in this one. So feel free to stop me anywhere. So starting off, this is the normal. When we say machine learning, you can say is in between the two cases where artificial intelligence is a vast area. Yeah, at one time you had expert machines, electrical background people know expert machines, then natural language processing, fuzzy logic, robotics. They are all different applications of AI. Not going into that, I'll be restricting mainly to the machine learning and deep learning part. So deep learning is actually a subset of this machine learning. So you can say it is by this Venn diagram, you can see that artificial intelligence is in generally having many things. Out of them, we have a vast area of machine learning coming into picture, and then the next stage is your deep learning. So nowadays, with self-driven cars and those things, deep learning is very much into the focus. And in second half, Bhuya sir, you will be discussing computer vision with these things. So you will be more aware how they are doing it in higher dimension. That is, once you have it in computer vision, you have multimodal and multi-channel signal analysis using these machine learning and deep learning techniques. I think you'll be discussing those things. So what this artificial intelligence is, if I go for a more general overview, I start off with what Alan Turing. I hope you remember the movie name. Anybody? Movie on this Alan Turing's movie, English movie. One movie was released. Anybody remember the movie name? There was a anyone of you remember? You don't want Manipur students watch a lot of movies, as far as I know that. You remember the movie? Anyone? Hollywood movie on based on Alan Turing? Nobody has seen that.
No response is coming, sir.
No, sir.
So this
No,
is a
sir.
very nobody has seen. Okay, So you can Google Allen turning and you can see. So that was actually based on. I'm giving the hints. That was based on the World War where these enemy, or you can say the Germans, were sending messages, coded messages, and every time they had to employ a lot of decoders to do that. So what Alan Turing did is that he had tried to make a machine or a computer at that time which can predict whatever the random kind of input is coming, means they are able to predict what message is actually encoded. Okay, so he did it in way back in 1950. So based on him, there is one particular test which is called the Turing test. So those who are having the Google, you can Google and see what the Turing test is. It is based on making a particular software which can make you feel that if you are speaking to it, it is like you are speaking to a person. So for example, if I'm able to make a code which is like a chat box, like nowadays most of you are having the most of the banks have chat bots which where you can chat. I have a say credit card problem, you can use WhatsApp, or SBI is having Cia, ICICI Bank is having some thing, HDFC is having Eva or something. So nowadays chatbots are very popular. So these are based on different learning algorithms where what they do is that you have to have some it is something like, say you are discussing something with your friend, so you are not able to see your friend, you are just called him or her and you are discussing with him, how are you, how did you, so you feel there is a human touch there whenever, even if you are not able to see him or her, when you discuss or you chat with him or her, you get a human feeling while chatting, that he is having some inherent, he or she is having some inherent connection with you. Or did you have your meal today? What did you have for breakfast, or what did you have for lunch? How did you cook this item? This kind of thing. So if you can make a this program where you can discuss with that particular program in such a way that you, if you don't know, you feel like this is not a machine but responding to you, but it is a program procedure. Based on that, every year there is a turning test. So you can Google for turning test. So every year a huge amount of money is coming for that, and they are given as prizes for those who can, those whose program can pass the turning test. So Alan Turing posed the main question that can machines think? So, or at least we can say plan to make them think. Means we can plan for having the machines to think without any human intervention. Means there should not be any human involved when the machines are thinking. So they will be able to take their own decision and go ahead and other things, and they can they can work standalone. So in a, it is a broad area of computer science where this you want to have some human kind of intelligence in the machines. So if you can do that, it is a great thing. So mainly presently the AI system is having your three different parts. So before going to that, all the three parts, whatever is there, is based on the idea of imitating human behavior, whether it is hardware based or whether it is software based, or various applications are there. So these things that we have here are mainly differentiated, and hypothetically this AI is grouped into three different types. The first one is artificial narrow intelligence, which presently is existing. Then artificial general intelligence, which some of the movies are based on that, and we want to reach this particular layer. And the artificial super intelligence, which if we reach will be in trouble, but still in sci-fi movies we are having this particular thing. So if anybody has any idea regarding these three, can you please say, or I'll go ahead. If anybody has any idea of these three things, what is artificial narrow intelligence, what is general intelligence, and what it is super intelligence? Anyone of the participants? Okay. So going ahead, first coming to the narrow intelligence, this is the present scenario. So it is the present day AI, or it is called the narrow AI, or you can say it is present day. Even though we are saying that my program can do this or my program can do that, still it is called a weak AI. Okay. The next one that is there, this narrow AI is more goal oriented. So here we say that the program is performing one task at a time and so on. So here these things that we are using, chatbot, self-driving cars, CD, Alexa and other things, are actually falling into this group. And these systems are called weak AI because they are not conscious or sentient. So they are not driven by emotions as humans are. If you say yeah, up to 40 marks is pass, so pass. Above 40, below 40 is fail. So if it is some teacher who is giving the marks, he'll think that अरे लड़का या लड़की को 39 मिला, एक नंबर दे देते हैं, बेकार में एक नंबर के लिए वो फेल हो जाएगा. So that is the human emotion. But if you put a machine there, then what will happen? 39 ही रहेगा और 39 में वो फेल भी हो जाएगा कैंडिडेट. Okay, so there will be no difference between 39 and this somebody getting 1 or 2, because if somebody getting 1 or 2 out of 100 cannot be passed, but somebody who got 39, at least if we think from the human point of view, अरे उसको एक नंबर या 0.5 दे देते हैं और राउंड होके तो पास ही हो जाएगा. So that idea is the humanness or consciousness that we human beings have. बट अगर वो गूगल फॉर्म में दिया और डायरेक्टली रिजल्ट पब्लिश हो गया तो ऑनलाइन एग्जाम हुआ, गूगल फॉर्म में एंट्री किया एंड व्हाट एवर द स्टूडेंट सबमिट, ऑटोमेटिकली रिजल्ट निकल जाएगा, डायरेक्ट मार्कशीट निकलेगा. ऐसा अगर होगा तो सो इफ द स्टूडेंट गेट 39, व्हाट विल हैपन? He or she will fail automatically. There will be no idea of making them this. It will be there if we write a code that those who are getting 37 or 38 or 39, we can give say 3 or 4 marks grace and pass them. But for that we have to provision the code in the system. If we don't provision the code in the system, the candidate is not going to pass anyway. Clear this part? So we use this information from any specific data set, and we do not perform anything outside. So that is the idea of the machines these days. So they will take whatever information you give, whatever instructions you will give, they'll follow your instructions, and it may be that they are self-learning or any other thing, but they will not be having the emotional point of view. So the basic idea is that we are having this particular case where the main idea is this consciousness or sentient. So this consciousness, what it is, that it is like a machine thinking that whether it is a person or a thing. So this thing is where when we say sentient means many things. What is means if I consider the opposite, it is insentient, or you can say unwitting, unfeeling, unaware kind of thing. So here what you are having is this particular thing is when I say the system or any computer or any program is not sentient, means this is not conscious at all. Okay. So the next phase is the artificial general intelligence. The next phase. So this is a bit, you can say it is strong AI, and here machines exhibit human intelligence. So if you can make, presently there is no AGI, it is exists in films only. So this, if machines can give some amount of human intelligence, then it is called a strong AI. So here the machines have ability to learn, understand and act, and that is indistinguishable from human. Means it has to be indistinguishable. Presently whatever is there, it is distinguishable from human beings. So once the distinction between man and machine is not there, this is the this artificial general intelligence, and turning test is just to make a chatbot which is uh, having something like AGI, but here what it is, we are not able to make up to AGI. We are just trying for the person who is chatting, he feels like there is AGI on the other side, and it is very easy to fool another person. But if it is not possible to fool everybody, because the different people have different IQ levels, so you can fool a person with less IQ more easily compared to a person with more IQ. So here when I say passing the turning test, here there is no demarcation of whether we are able to fool a person with what kind of IQ level. So this artificial general intelligence in general is just when the machine exhibit human intelligence kind of behavior and have the ability to understand, but it is indistinguishable whether the person is doing that or a machine is doing that. So presently they do not exist because they have to be conscious, have to be driven by emotion, they have to be self-aware. So if it is presently we have not reached this stage, the prediction is that by 2040 or something we may reach there, but that is just a prediction. If we work fast we may get it earlier also, and if we are not able to reach that level, maybe we will be getting it later also. So that is just a prediction. So using strong AI, what we can do is that we can build machines, we can strategize, perform multiple tasks with uncertain conditions. So that's why I'm repeatedly telling that this works in movies only. So you have to integrate the prior knowledge in decision making, innovative, creative ideas, like somebody who is drawing. You can ask the machine to draw, but it will not be like how a artist draws, because he will bring in his different emotions into the pictures, or a person who is composing music, or somebody who is working with artistry or any kind of art. So you can make systematic things, but you cannot make unique things. So that uniqueness that we have in human beings is, if we can replicate to some extent of that, that is your artificial general intelligence, and this is the stage we are yet to reach. So we are now in this particular artificial narrow intelligence state. If we have some unknown breakthroughs, we may reach the artificial general intelligence, whereas the artificial super intelligence is the last stage where we have a hypothetical AI which exhibits intelligence that surpasses that of the brightest humans. And apart from having this multifaceted intelligence of human beings or machines, there you have these different types of AI where it can have a great impact of humanity. But the thing is that here there are both pros and cons, just like we have studied earlier what are the pros and cons of science in school level. So similar to that, there are various pros and cons of this super intelligence, and there is no demarcation, means how it is there and how it is going to be, and how it is not going to be, and so on. So if you see, this is from internet. So the different AI source stages, if you see, artificial narrow intelligence, artificial general intelligence. So at about 2040 it is there, and once the machines are able to say decide like human beings, they will make machines of their own, and it will reach the super intelligence. So it is consider that now the jobs are being enhanced, but when AGI will come, the jobs will be at risk. And once AGI is there, it will be able to make itself more intelligence, like we human are making ourselves more intelligent with the help of these machines. They will be replicating them like the science sci-fi movies, and then the humanity might be at risk. So whether it is a savior or a killer, you never know. So with that particular knowing not and not knowing what is there, I am starting off with the next aspect of AI, that is machine learning. So before I go to machine learning, let me know if you have any questions up to this. Here I have discussed AI in general only. Rather, what I have discussed is the general aspect of AI, how it is there, and there is no mathematics involved and no other thing involved, and it has a lot of applications, but I am restricting myself to the ML and DL part of AI, not going to fuzzy logic, not going to expert systems, not going to NLP, not going to robotics and other different applications. So till this the initial AI introduction, if you have any questions, kindly let me know, or I'll go ahead with the machine learning. So I can go ahead with the machine learning. Okay, so coming to the machine learning part, this is the next stage, you can say, as per the Venn diagram that I discussed. So here what we have is, it is a subset, as I had shown you in the Venn diagram, and here we have the statistical learning algorithms, and here the systems have the ability to learn automatically. So what we are trying is that we not reach the AGI stage, but in this weak AI stage, we are trying to have machines with a few set of rules. They are trying to learn themselves, but within a constrained environment. That is the basic idea. So from the experiences, without being explicitly programmed, they are trying to learn themselves. So most of us use this machine learning in our day-to-day life. Maybe when you are using Netflix, YouTube, and Spotify, any other engines, search engines where Google Assistants, voice assistants, Alexa, and those things are there, they suggest based on you. Nowadays, even the ATMs, you remember, anybody using HDFC ATM will see that if you insert the HDFC ATM card, based on your past usage record, it will say that if somebody is always drawing 5,000 out of the ATM or 10,000 out of the ATM, it will suggest that do you want to take out 5,000 rupees or do you want to take out 10,000 rupees, because that is your habit. You always take out, say हर 5 दिन बाद 5,000 रुपए उठाता है, या फिर हर 2 हफ्ता में 10,000 रुपए उठाता है. So there are different kind of people having different behavioral traits, and HDFC has already done that in their machines. So you'll see that they just based on your last transactions records, they will just suggest you, even if you are using some other ATM card in a HDFC ATM. If anybody has tried, you can try that one out. HDFC का ATM में तो आपका SBI का या Axis का भी अगर घुसाएंगे, so it will automatically suggest you, do you want to take this much amount? Okay, that is based on your last few transactions, means how much you have drawn cash in the last few ideas. So the presently, even your you will see Google something about shoes, or in Amazon you are looking for shoes, and then in the same browser you are logging into Facebook, and then you will see advertisements of different shoes. Okay, so that is a common feature, because nothing comes for free. If you are not paying anything to use these services, that means you are the product. People are using you as a product. So that's why you receive advertisements, you receive your spam mails. वो Facebook वाला जो मेल है उसमें Amazon का एडवर्टाइजमेंट आ जाएगा शू का, अगर पहले शू सर्च किया तो. So that is how the systems work, and machine learning and deep learning is working a lot on this particular domain. And here we use this machine learning algorithms to train, and based on the training, with a lot of data coming in, you will be the system will learn itself and will suggest you different things on its own. So these machine learning algorithms can broadly describe into 3 categories. Coming to these, the first one is your supervised learning, where you are having training data which is labeled, and the goal or the target is correctly labeled to new data. I'll be discussing this in details. Then you have the reinforcement learning, where you have the training data is unlabeled, and the system receives feedback from its actions. The basic goal is to perform better actions here. And the third one is unsupervised learning. So supervised in here also it is unlabeled, and goal is to categorize the observation. Now basically supervised learning is something like learning with a teacher, And whereas reinforcement learning and unsupervised learning are learning without teacher, but there are two different ways in which you are doing. You can see in both reinforcement learning and this unsupervised learning, the training data is unlabeled. Unlabeled means you don't have any labeling going on there. So what happens here is that here you have these particular uh, system, but there is a difference between reinforcement learning and this. Here you see in one, you have a system receives feedback from this actions, whereas in the other you are not having these. The goals in both cases are categorized, but one based on the actions, whereas the other is not based on the actions but based on the observations. So if I discuss in detail, this is how supervised learning works. So it is called the learning with a supervisor or learning with a teacher. So in this learning with a teacher, you see you have a raw input data. So teacher is sitting there, and based on the algorithm, it is processed and they are categorized into red, green, and blue. But it is how we teach a kid also. If you have a kid at your house, what happens? You will say give the kid some objects. Say some is triangular, some is circular, and some is say say rectangular or something. So what you say that you being his parent or teacher, you tell him or her, अरे जितना सब गोल बॉल जैसा है उसको एक ग्रुप कर दो, जो ट्रायंगल जैसा नोकीला या शार्प वाला एज है उसको एक ग्रुप कर दो, एंड जो भी है, एंड इन केस ही और शी मेक सम मिस्टेक्स, यू आर देयर टू गाइड हिम, और अरे अरे ये वाला वो रेड बास्केट में नहीं, उसको ग्रीन बास्केट में डालो, ये वाला ब्लू बास्केट में डालो. So that is how you do the supervised learning. So you have input raw data, and there is a teacher or a supervisor who when the system is training itself, he is actually guiding it. Once the system is trained, what happens? The teacher is sitting back. The kid who was initially separate, who was initially being trained to separate the circular, triangular, and the rectangular objects, now he or she on his own can demarcate. If it is having a minimum level of intelligence, the kid is having a minimum level of intelligence, he or she can do. So object recognition and other things are done here. Okay. So this is the supervised learning. So this sorry, so this here we have the algorithm which takes the known set of input data set, and here from the responses of the output, applying any classification or regression program, it will do. But before that, it needs a training. It has to be trained accordingly. So as the training will go on, the system will understand, okay, that the kid will understand the sharp edges, they should not means they should be grouping as triangle or any other thing. The rectangular ones will be in say basket blue, triangular ones in basket green, and those who are circular or spherical will be in basket red. So that kind of demarcation will be happening in the supervised learning. Going ahead, you have the next is the unsupervised learning. So in unsupervised learning, you see the teacher is missing, teacher or supervisor is missing. You have an algorithm, and here some input data is there, and it is being processed in a way, and the system is grouping. So what you do, you give the kid some, here in this case there is no person sitting with the kid, you are giving it all the triangular and circular and other things, and the kid is actually grouping them. He or she is grouping them into triangle, circle based on, अरे ये बॉल जैसा है तो इसको इस रेड बास्केट में डालेंगे, ये ट्रायंगल जैसा है तो उसको यहाँ रखेंगे. So there the algorithm is to see if any sharp edge is there, put it in the triangular basket, see if any all sides are similar or not, then you put it in the rectangular or square basket, and if you see it is spherical shape, you put it in the red basket. So this is a basic algorithm which you can give to a kid, and the kid will, without the guidance of the parents also, he or she can automatically group them, unless they are of different colors. So you may be doing in different way. One kid may group say all the red, whether triangle or square or rectangle, all the reds in one group, all the greens in one group, all the blues, or one kid may, if they are of all same colors based on the shapes he can do, because you have not told him how to group the thing. Initially you were telling him to group it based on shapes or group it based on colors, but now you are not telling him anything. So if you are not telling him anything, he will do on his own. So if you have two kids where initially you had supervised and done the grouping, now you are not grouping anything. So when you are not there, the one kid may group all the blocks based on color, one kid may group based on the shapes. Okay, you have not told him anything. Or somebody may group in two ways: color wise shapes or shape wise colors. They can do in that way also. So in unsupervised learning, there is no thing based on the unknown output is generated based on interpretation. The interpretation is the kid's interpretation. You have not asked the kid to group shape wise or group color wise. If you say color wise, it understands, okay, I have to group color wise. If you say shape wise, it understands that I have to group shape wise. But if you don't say anything, it will interpret on its own and it will decide on its own how to group them. So that is your unsupervised learning. So here we don't have any label data. There is no grouping there. So you have to group, make your own group. You have to cluster and sort the unsorted information and finding similarities, dissimilarities, patterns, data. You have to explore the data and do the analysis and so on. Okay. The last one is the reinforcement learning. So here what happens here, it is something like a reward and punishment kind of thing. So it is something like there is two ways. You can tell the kid not to touch the flame of fire, or you can leave the candle burning in your room. And for the first time, if the kid sees the flame is burning, he or she will go to touch it because it is attractive. So he or she will try to touch everything. So they will try to touch the flame. So once he or she touches the flame and his or her finger gets burnt, she understands that, okay, earlier with the teacher you were saying that aage mein you don't have to put finger in the fire, but now what you did, you left the candle burning, and the kid is seeing fire for the first time. He or she may be feeling attracted to it and will be going and touching the thing. Once he or she is touching the thing, he or she may burn the finger. So once he or she burns the finger, then he or she learns on the same way that, okay, I should not be touching the flame. Okay, so that is reinforcement learning. So he or she got a punishment by burning his or her finger by touching the flame. So this is one type of reinforcement. Another type of reinforcement may be that you can put oranges, apples, and all the different fruits together. Now the normal behavior of the kids is to bite the things. If he or she bites the apple, will feel like, okay, it is tasty. But if they bite the orange, they do not know that they have to peel the orange and have it. So they will feel they'll not like it, or even if they've bitten it harder, they may like to eat it. And if you have given a ball also along with that, they'll bite it and they'll say, "Arey, to daat mein bahut dard ho raha hai because I have bitten a ball," because they don't know what a ball is and what a orange is, what an apple is, and other things. So in reinforcement learning, if you leave these things to them, as the playing will go on, they'll bite the things and they'll understand that, okay, ye khane wala cheez hai, ye nahi khane wala cheez hai. So this kind of things is based on reward and punishment. Reward means this thing has to be repeated. Punishment means this thing should not be repeated. Okay, so that's why we have this reinforcement learning. But here the advantage is that this learning may be slow, but without any involvement of teacher or any other thing, just by automated reinforcement or automated credit blame or automated reward and punishment, the system learns on its own how to do. In both previous one and this one, you don't have label data, but in the previous one, based on the experiences they gather, and here they gather here also, they gather experiences based on the observation and other things. But difference is that here there is a credit or punishment, means एक बार fail हुआ तो next time से ये subject अच्छे से पढ़ना है. So this is the basic idea here. So here learning is done continuously by interacting with the environment, and this is in a trial and error mode. It takes long to learn compared to the previous one, but it is a fixed learning, and then later on there is no errors in this particular learning, because already the credit or the punishment or the reward is already given, and there is strong kind of learning evolving from this, but it is time taking. Okay, so clear up to these three parts: reinforcement learning, supervised and unsupervised learning. I've taken the pictures from internet only. These pictures are available internet. So going ahead, coming to a few applications of machine learning. The first one is like handwriting recognition is very common. One of my colleagues also have done that. Some of my BTech students and MTech students also have done that. Means you are having written letters to be converted to digital letters and many more. These are just a few applications which I'm doing. The language translation, translate spoken or written language. You have Google Translate for that. Then speech recognition, voice. So you have Siri, Cortana, and Alexa doing this regularly. Then you have image classification. You have labeled images based on that. Say for example, Google Photos, and then your autonomous driving is there. Enabling the car. These are the few applications. So the coming to the features that we are having, the features are nothing but the observations that are used to form the various predictions. The most popular ones for image classification, the pixels are the features. For voice recognition, the pitch, MFCC. Those who are working in speech processing or natural language processing, they know that MFCC, pitch, Cepstral, and other things are the features. Then for autonomous cars, you have the Google Maps, you have the data from the cameras, range sensors, GPS, which work as the features, and based on these features, the system learns. So you need to give features. Basically, in machine learning, what happens? You do the feature extraction with various algorithms. Whatever the features you detect for various or applications, you have various features. These features work as input to the neural network, which is the brain kind of modeling, which I'll be discussing after this. And then the system learns and it works on. So there may be extracting of relevant features which are important for building a model. Say for the time of the day is a in irrelevant feature when classifying the images, whether it is a ball or a bat or a any other thing. If I say time of the day is important, it is irrelevant. Whereas if you are classifying emails based on whether it is spam or any other thing, then the time of day is relevant. Because say you got a mail from me at say night 2:30 p.m. So it is very rare chance that I'll be awake in 2:30 p.m. and sending you a mail that I am having shortage of money or so. So these kind of things are there. Just because you are in my mailing list, I will not mail or any other thing. Okay. So next, coming to this, you have this common types of features in robotics. Robotics is actually an application of AI, and nowadays you have ML and DL being applied in robotics. So there, if you have the camera for the robot, it will be working based on the pixels. It may be based on say collision detection and avoiding collision avoidance. There you can use data based on sonar, laser, or rangefinder, means whether there is any object in front of that. If there is some obstacle in front of the robot, it has to change the track and other things. Then movement based on the encoder values, and gyroscope, accelerometer, compass are also there for the movement of the robots. So these are some features which a lot of examples are very common. People working in different research areas are applying these machine learning algorithms there. So if you want to measure the success for the classification of that, it may be say based on the most common ones are fourfold. The first one is true positive, means you are classifying and you have exactly classified the relevant thing. Then true negative, you have correctly identified as not important. And false positive is incorrectly labeled as relevant, and the false negative incorrectly labeled as not relevant. So it is something like what we do. One of my scholars, Dr. Sina Majid Kumar Singh, he has done the heart ECG abnormality detection, or PCG, that is phonocardiogram abnormality detection, and other things. There they have used this particular thing. It is something like, say we want to reduce the say work of the doctors. So how will you reduce the doctors? Because say daily hundreds of patients are going to the doctors, and India is a big country, and you know that relevant that we don't have sufficient number of doctors. So as we don't have sufficient number of doctors, so we need to arrange doctors for those patients who are more needy compared to those who had just have had some doubt and they have come there. So wasting the doctor's time on them will be more, maybe fatal for those who actually need the doctor immediately. So if you have some AI based or machine learning based classification algorithm who will initially take all the vital statistics or the inputs from the participant, and based on that it will actually decide whether he or she should go to the doctor or not. So say there are four-headed kind of things. What are the four-headed kind of thing? One is that there are two things that the person can be. What are the two things? One, the person may be needing medical assistance, or the person may not be needing medical assistance. Means he may be a sick person or he may be a healthy person. This is the first two classification of the person. Whereas the system is also based on the data or features that are extracted by BP ले लिया, sugar level ले लिया, body weight ले लिया, BMI ले लिया, heart condition ले लिया, just like what happens in normal full body checkup. I think many of you have done full body checkup in different say big hospital, Apollo and other things. So we take the initially whatever the MD medicine does. If we don't take it to the MD medicine first, we ask the system to decide whether he or she should go to the MD medicine for some suggestions or not. So how we'll do that? First, it is true positive. True positive means here the person is sick and the system is saying that he or she is sick. Fine, that is okay. That he or she will go to the doctor. Fine. Second thing is that true negative. True negative means the person is not sick, he is healthy, and system also said अरे ये तो healthy है, इसको MD medicine के पास भेजने का कोई जरूरत नहीं है. Fine. So that is true negative. So these two cases are both good. Means if out of 100 we have say 50 true positive, सबको डॉक्टर के पास भेज दो, and we have 50 true negative, उनको 50 को घर भेज दो. It is very simple as that. But problem is that there are false positives and false negatives also. Now those false positive things and false negative things, one is okay, whereas the other is not okay. One is okay means what? One is okay because say the person is not sick, but your system, the machine learning system says that no, he may be sick. Send him to the doctor. तो घूम फिर के वही हुआ, जिस मशीन लर्निंग का कोई काम नहीं हुआ, वो खुद बोल नहीं पाया कि ये सिक है कि नहीं सिक है, बट इट इज सजेस्टिंग दैट ही मे बी सिक. तो वो तो ऐसे भी डॉक्टर के पास जाने वाला था, वो फिर से चला गया, नो प्रॉब्लम इन दैट. बट प्रॉब्लम इज विद द लास्ट वन, एंड इट इज वेरी डेंजरस प्रॉब्लम, दैट the person is sick but your machine learning algorithm says that he is not sick. So what will happen? He will go home, but actually he is a sick person. He is having some abnormalities. He should have gone to the doctor. Maybe the doctor would have been able to detect what problem he or she is having and could have suggested some medicines. So that problem is the fatal one. Means when you are sick and you are detected as not sick. If you are sick, you are detected as sick, you go to the doctor, fine. You are not sick, you are detected as not sick, you don't go to the doctor, that is also okay. You are not sick, but the system tells that you may be sick, you go to the doctor, fine. Doctor will then say, okay, आप तो बीमार नहीं है, vitamin का tablet लीजिए, go home, fine. But the most fatal part is the this main false negative one. When you have incorrectly labeled as not relevant, this is the most problem one, and maximum scoring algorithms are having putting high weightage on this one because this should not be happening. If this happens, it is fatal. So here, based on the different systems, the classification is done. So you measure the success based on the first two more compared to the last two, out of which the last one actually generates more negative effect compared to the positive effect. Okay, so these are the four important measuring things, based on which what you do. Say for example, I want to identify the cat. So you see the first one, it is a cat image. You say yes, it is a cat image. It is a true positive. Next one, is it a cat image? No, it is not a cat image. So it is a true negative. That is correctly identified as it is not a cat. The third one, false negative. False negative means it is a cat image, but you are saying that it is not a cat image. Okay. The fifth one is false positive. False positive means here it is a car image, but you are saying what? It is a cat image. Now, what will happen to the last two image? Can anybody tell me? The eagle image and the other image?
Sir, false negative.
If it is negative and that one is positive?
False positive, false negative.
Yeah. So you have false positive and false negative. And if it is the other way around, it will be true positive and true negative. Now, based on this, any kind of classification you may be doing here. So these are the three, most of the research papers, if you refer, these are the three categories based on which they identify precision, recall, accuracy. Other than that, there are many more parameters. Different algorithms are tried upon, but round and round they go. Along with that, sometimes you have the sensitivity, specificity, and other things also. I'm not going to that. So here for precision, mainly it is the percentage of positive labels that are correct answers. So what is precision? Precision is the total number of true positives divided by true positives and false positives. Means actually how many positives were there, and out of which how many are actual positives and how many are actually false positives. So you take the percentage of that, and that is the precision. So if in any way the false positives are 0, then you have 100% precision. Okay. If the false positives are not 0, even if it is a single value is there, then this is not 100%. Okay. Second is the recall. Recall is how much correctly you are say being able to recall the thing. Means here the percentage of positive examples that are correctly labeled are being correct. So here you have the true positives divided by true positive and rather false negatives, not false positives in this case. So you can see the basic difference between the precision and recall functions. In one case it is true positive divided by true positive plus false positive, whereas the other is true positive divided by true positive plus false negative. Okay. So the third one is the accuracy, how much accurate you are. So that is based on, because you are accurate based on true positives and true negatives. As long as if you have 100 candidates and you have 50 true positive and 50 true negative, and total number of samples is 100, so 50 plus 50 divided by 100, if it is equal to 1 or 100%, so you have 100% accuracy. But in case some of the positives are wrongly classified, some of the negatives are wrongly classified, then you don't have a 100% accuracy. You have anything less than 100%. Okay, so these are the basic three formulas that are being applied in all this research. And coming to the training and test data. So the training data is the data which is used to make the model learn. The test data is the data which is used to assess the accuracy of the model. There are a lot of overfitting problems, means when the training data is it performs poorly on the test data. It is something like, say, the teacher is teaching a subject. He is giving all the solved problems in the internal tests, and the student is getting good marks क्योंकि उसने तो पूरा समझ में आया नहीं समझ में आया, he or she has memorized all the solved examples. Say I am teaching digital signal processing from ProAkis, and I have covered say 6 chapters, and all these 6 chapters I am giving only solved problems as in the question. So if I give all the solved problems and the students have practiced the solved problems of ProAkis well, so he or she will be getting very good marks, 70-80% marks लेके आ गया. कोई क्वेश्चन पेपर खोल के देखा कि अरे ये तो एज पर एनबीए गाइडलाइन सब कुछ है, सब कुछ सब चैप्टर से क्वेश्चन है, सब सीओस पीओस वो सब कुछ जस्टिफाइड है. इट लुक्स गुड, बट द कैंडिडेट हैज नॉट लर्नड एट ऑल. Why? Because I have not given any unsolved problems. जितना solved problem है वही दिया है, और वो भी एक somebody may have understood it, somebody may not have understood it. We might have say memorized the answers. इसके बाद ये लिखना है. लिखना है क्या किताब में लिखा है सर सेकंड स्टेप ऐसा होगा तो ऐसे ही होगा. So this is a common scenario with the students. So they do it. But what happens? The same student who gets highest in my DSP paper, गेट में वो सिग्नल प्रोसेसिंग या सिग्नल सिस्टम्स में उसको पूरा नेगेटिव मार्किंग आ जाता है, बिकॉज सिग्नल सिस्टम सेक्शंस में सब अनसॉल्व बिकॉज दे आर द बेसिक्स आर नॉट क्लियर. Whereas a student who might have got less marks than him, if his or her basics are clear, he will be getting very good marks in the signal systems part compared to the person who has got highest marks in my subject. Okay, so that's why this is called a overfitting problem. Overfitting means in the training he or she is performing very well, but in the testing the accuracy is falling down. Okay, so you can see here when the red one is the training data and the blue one is the testing data. So in general, always training performance is much better than the testing. Okay, so that happens in general for any student or any teacher or any system. Okay, so going ahead, this bias and variance is based on the data set we can have. It is bias is the expected difference between the model's prediction and actual target or the truth, whereas variance is how much the model differs from the different training sets. So it may happen that you are having, say for example, just if you bias is something like you go to the sabzi market and there the person selling potatoes is using a metal bowl. So what he does is that he puts a blank metal bowl on the weight scale. Now you have digital scales. I think in Manipur also maximum shops are using digital scales. So you'll see that weight he has calibrated in such a way that the metal bowl is actually giving 0 kg. Why? He has calibrated it to 0 kg. Now you are assured that okay, मैं आलू डालूंगा उसमें तो वो बर्तन का weight उसमें नहीं आएगा. Okay, so he has given some bias which is making actually the weight of the bowl, metal bowl or iron bowl is not 0 kg, but he has calibrated it with a bias which makes it 0 kg, so that you are assured that when you are putting the potato in the bowl, it is the weight of the bowl is not coming. Getting? Now, what is the variance part? Variance is how much the model differs from among the training sets. Now it happens that you take 1 kg of aloo from somebody and go to some other shop, and in that weight machine it is showing 900 grams. That means he is having some error in his weighing scale, or he has done some thing there due to which he, from everybody he is stealing 100 grams. So you can have various scenarios in this case. First one is high bias. The model makes inaccurate predictions on the training data. High variance, where the model does not generalize to the new data set, because variation, because that is does not generalize. As इस दुकान में 1 kg होगा तो दूसरा दुकान में भी तो 1 kg होना चाहिए. If there is variance, that means the model is not generalized with new data sets. And low bias. Low bias means model makes accurate predictions on the training data. Here in this case, low bias means अभी अगर वो बाउल को डाला तो उसमें instead of 0 kg आया -0.1 kg. So -0.1 kg में तो मैं खुश हो गया, ये तो मुझे 0.1 kg एक्स्ट्रा दे रहा है आलू का. 1 kg होने के लिए 0.1 एक्स्ट्रा. Whereas for high bias ये तो उल्टा हो जाएगा, means it will be +0.1. And low variance means the model generalizes, means यहाँ पे भी 1 kg होगा, वहाँ पे भी 1 kg होगा, कहीं पे भी जाएंगे it will be 1 kg. So this I'm just giving hypothetical examples to, without going into the mathematics, to discuss what this bias is or the variance is. So based on this, here uh, we can have these different scenarios here, and then we can deal with this. Okay, so based on this, we can have different data sets. So these are the some of the algorithms which are very popular. One is the linear regression, one is the decision trees, one is support vector machines, k nearest neighbor method, KNN in short it is called, and your neural networks. So you have a lot of different methods uh, going on, and these are the five. These five are the popular ones. So here these are very common, and many of you
நோட்
might.
பண்றீங்களா மார்க்கு?
Okay, so has anybody used any of these methods? Linear regression, decision trees. Nowadays, Python programs, MATLAB programs, and many other systems are having. I'll be discussing a few tools also there, Weka and others, which already have these things inbuilt. Anyone of you used any of these algorithms, supervised learning algorithms? Anyone used any of this algorithm? Or any of the applications regarding your UG, PG or PhD related projects? Okay, so these are very popular algorithms, and a lot of research papers are available, and they have been used irrespective of the fields. A lot of different fields they have been used. They're very popular. Okay, the codes are available in GitHub and other things. Nowadays you don't need to code, but it is something like if you don't know what is the basics there, you using the code may lead to some unwanted kind of results. Anyway, so these are the supervised framework. The different tools are there. Scala, R, Java, then Python, then these Weka is one of the popular ones. TensorFlow is there in Python. Okay, Scikit is also in Python. These are the different supervised learning frameworks which are available, and you can use them accordingly. Okay. So coming to the neural network, before I go to the neural network, you can see this is the biological neuron which you have studied in your school level science. So the basic advantage of this thing is that what you are having here. So what you are having here is that you are having this basic neural cell, and there you are having this axon, synapse, and these are connected to various so the whole set of nervous system is working. Our biological nervous system is working. So you are having micro actuators, you are having energy flows between the cell to cell via these axons and dendrites. So what happens here is that if you compare with the speed of neuron, the neuron is slower than what happens in the silicon. Those who are from device field, they know that the speed of silicon gates are faster than our biological neurons. But what is the advantage of our biological neuron is that it is very highly connected. Like I am from Tripura, many of you are from Manipur and other states, but you'll see that in small states what happens is that everybody knows everyone in the state. So what happens is that the information flow is very much faster, and if whether there is corruption or there is no corruption, the information is there with everybody. Okay, because it is a small state. But if you take a very big state like Madhya Pradesh or any other things, एक corner का आदमी दूसरा corner का आदमी को नहीं पहचानता है, unless he or she is a celebrity. Okay, so that basic system is there. So in biological neurons, what happens is that all of them are connected to all of them. That is like our small states. So what happens is that even if somebody is putting a small drop of water on your hair, I'm telling hair, not head. Okay, so somebody may be having a lot of hair. In that also, even if somebody is putting a small drop of water, our hair is normally dead cell. So still we are able to feel something. Okay, that feeling is coming just because our system is totally and fully connected. So that is the basic idea of neural networks. And there we have a basic neuron, and we are trying to replicate the biological neuron with the artificial neuron, and there we have synapse, and we are there we assign some weights w1 w2 up to wm, many of them, and we are having some linear combiner or adder there, and then we have a activation function which is making the decision, and this activation function may be thresholding kind of straight kind of function, or it may be sigmoidal or tan hyperbolic kind of smooth function based on whether it is a linear system or a non-linear system. So basically the neuron diagram looks like this, where you have the inputs coming. We have a bias like the one I discussed. We have a local field. We have the activation function. Our biological neurons also work in a similar fashion. So what happens here is that the bias based on this control, the bias is working. So one way is to what you can convert the bias into one of the inputs. So you see here what we have done is that we have shifted the bias, which was earlier here. This you can see in this particular case that we have put a new weight W0. I think you can see the screen. We are putting a input 1. If you see the earlier slide, here you have the bias in this portion. Okay, so this bias is actually taken and it is shifted here, and this local field that is there is some variation that you are putting. So based on that, what you do, you want the transfer function to be here. Say for example, I have a AND gate. So all of you know about the AND gate. What is AND gate? AND gate is you have A and you have B. So you have for 0 0 0 1 1 0 1 1. So what are the outputs? In AND gate this is 1, and in OR gate this is 0, and rest of them are 1. Okay. So what you have to do here is that here you have to make this one as 1 and rest of them 0, whereas in this one you have to make this one 0. So this is for OR and this is for AND. I hope all of you know about this, isn't it? Because digital gates all of you are aware of, so I'm taking a very simple example. So the bias and variance here, the local field that you are having means whether you will be putting the local field in which the green line, blue line or black line will depend on how you are handling it. Means if I am having this particular thing, you know you have 0 0 here, 0 1 here, 1 0 here, and 1 1 here. So if it is this gate, it is here, and if it is the other gate, it is here. Okay, so this line is for what? This is for the AND gate, and if it is the OR gate, the line will be here. Clear this part? Meeting, I'm just explaining very simple AND and OR operation.
Yes, sir.
So this is the how you'll change the local field, and based on that you can do this operation. Okay, I'm just explaining simple. If it is a simple linearly separable thing with one dimension of separability. If I take a XOR gate, obviously the dimensions will increase. And if you take a very complex problem like say handwriting identification, it will have more number of dimension, more number of analysis to be done. Okay, so this I'm explaining with a McCulloch-Pitt neuron. You can see the neuron here. This is a simple AND gate. I am having x1 and x2 and they are being added to give you output y. And here the weights that I am putting, what are the weights? The weights are 1 and 1. So now I have to devise an equation which makes this output y as OR gate. AND gate. So you can see here how we are doing this. Here I put what? So y in is this, and this is my thresholding function. So what I am doing, if y in is greater than equal to 2, output is 1. And if it is 0, if it is less than 2, it is 0. Okay. So this is working as an AND gate. Fine. X1 and X2 are the inputs. Y is a single neuron. And 1 and 1 are the weights in these two inputs. And the function that I am applying, capital Y is equal to F Y in, is 1 if Y in is greater than equal to 2, and it is 0 if it is less than 2. Clear? It is a simple AND gate. The same thing I can make a OR gate. उसमें तो मुझे कुछ करना ही नहीं है. This is simple operation. You can see. All of you are aware of digital, so that's why I have thought of taking up digital using the neural networks. Okay. If you make it OR gate, here I am just randomly using 3. You can use 1 also, no problem in that.
Any previous slide?
Previous slide.
Okay, sir.
Simple, just adding two numbers. We are having a summation and just I'm putting a thresholding function. Thresholding function is the decision maker. Okay. यहाँ पे 1 डाला है, इसमें 3 डाला है. 3 की जगह 1 भी डाल सकते हैं आप. No problem in that. Okay. Only thing is that 3 होगा तो 3 वाला equation होगा, 1 होगा तो 1 वाला equation होगा. Okay, so this is just the other thing here. अभी thresholding function 3 करके डाला है तो 3 डाल दिया, 1 डालेंगे तो 1 डाल देंगे. You can just change it. Okay, it is not a very big deal. You just have to make this 1. यहाँ पे 1 कर दीजिए. यहाँ पे you make it 1. You make this one also 1. You can make this one also 1. I have purposefully put 3 so that you can understand. Means the number is just a factor. अभी 3 से ज़्यादा better 1 होगा because it will have less complexity and there will be less number of multiplications involved. Okay. Clear this part?
Yes, sir. Yes, sir.
Okay. So going ahead, I am putting the NOT gate. NOT gate तो simple है. 1 डाल दिया, उसका उल्टा logic लगा दीजिए. So you got the NOT gate. So this I think I don't need to explain. सिंपल है, उल्टा लॉजिक लगाया है. लेस देन 1 को 1 कर दो, ग्रेटर देन इक्वल टू 1 कर दो. एंड वी इलेक्ट्रॉनिक्स गाइज आर मोर अप्लाइंग दिस इन ट्रांजिस्टर्स और FETs or CMOS, जो switching whatever we are putting is based on this NOT gate only. Okay, so I'm not explaining this and this is very much self-explanatory I think. Now as you know NOT, you know AND, you know OR, so I'm going to the next gate which is called the AND NOT. Okay, AND NOT means it is a special case where I want to allow one person. Say I have two people, person A and person B. I want person A to work. So I'll say that person A ही काम करना है और B काम नहीं करना है. Or I want A to come and B not to come. That is called a AND NOT operation. Okay, so this AND NOT operation is something like this. So I want X1 and not X2. So if I want X1 and not X2, this is the operation. You can see here what is happening. You get only 1 for X1 and X1 equal to 1, and this is the only case where it is 1. Okay, so this is called a AND NOT operation. In some of you, if not taken up in your UG classes, I think, have not studied N naught. N naught is nothing but it is a mixture of and not together. Okay, it is something like I am putting a NOT gate here. Means here what I am doing is I am using something like x1 is here, and here I am putting I hope you got that. This bubble is taking the negative of x2. Okay, so as this bubble is making the negative of x2, so that's why what is happening when we have x1 and x2 both equal to 1, at that time actually x2 is inverted and you get a 0 there. So y is not equal to 1. Okay, getting this part, what this n naught is? Do I need to explain the threshold function? I think you are getting the threshold function. Threshold function में क्या हो गया? It is x1 minus x2. So only when x2 is negative, means at that time only you are having this 1. Getting this part?
Sir, and not means not is followed by and.
Yeah, you can see the diagram. One of them is actually complement. X2 is complement. That is the thing.
X1 may be complement, sir.
Yeah. Then it will be the reverse. In that case, this one will be 1. It can be, if I make the other way around, if I make it like this, then this will be 1. Okay.
Okay.
But why I am explaining AND NOT is that you can make XOR with 2 set of AND NOTs. That's why before going to XOR, I was explaining this. Actually, these are 2 AND NOTs together. XOR, I am explaining XOR in terms of 2 AND NOTs. X1 and not X2 or X2 and not X1. मान लीजिए कि वो सुनील जी और मेरा दुश्मनी है, तो हम दोनों एक काम करने जाएंगे. सुनील जी जाएंगे तो हम नहीं जाएंगे, हम जाएंगे तो सुनील जी नहीं जाएंगे. So it is something like that. So if you are having something like that, it is a XOR operation. Any one of us can do the job. Both of us are digital teachers. Say he will teach or I will teach. दोनों नहीं पढ़ाएंगे और दोनों में से एक भी नहीं पढ़ाएगा, वो भी नहीं होगा. So हम दोनों में से किसी को डिजिटल पढ़ाना है, but both of us are not ready to take the subject together. So I hope this part is clear. What I am doing here is that X1 and XOR of X2 is actually a combination of X1 and not X2 or X2 and not X1. So we are taking it in 2 stages. Z1 and Z2 are initial stages, and the combination of Z1 and Z2 is your Y. So here you have the OR working here. This is the OR operation, and this is the AND NOT, and this is another AND NOT. So together, what we are having 2 demarcations. So rather, if you see the operation here, okay, you see what is Z2 and Z1. This is a function here. So we have 2 set of parallel things going on here. So what happens? So this is the transfer function for XOR. The thing has become a bit complicated compared to the previous AND, OR, AND NOT, and NOT is because now, because of XOR, what is if I want to draw it in the earlier diagram, यहाँ पे 0 0 है, यहाँ पे 0 1 है, यहाँ पे 1 0 है, and यहाँ पे 1 1 है. Now I need to take in XOR this area. So if I need this area, I need 2 demarcation line. One is this demarcation line, another is this demarcation line. दोनों दो डिमार्केशन लाइन, दो एंड नोट से आएगा, और इसके बाद द और इज डिसाइडिंग कौन सा वाला शेडेड पोर्शन है एंड कौन सा वाला नॉन शेडेड पोर्शन है. So now actually you are not having a single linearly separable operation, but you are having two set of linearly separable operation together making the XOR gate. Okay, clear up to this? If anybody didn't get this part, this is a very simple, means instead of taking big problems for neural network, I have taken up simple digital gates, and all of you know digital gates, so it is more self-explanatory how the neural network is working. Clear up to this? I can go ahead?
Yes, sir.
Okay. So if I take a bigger network, what happens? We have hidden layers also, but the operations between each layer to each layer is similar. We have input layer, now अभी बीच में hidden layer आ गया. Then we have the output layer. So that is what had happened in XOR. XOR में भी बीच में दो hidden layer आया था और इसके बाद output layer है. So what has happened here is that here you have, instead of a normal thresholding function, we have a sigmoidal function. Okay. This is one of the common sigmoidal functions. There may be any other function also. Those who are using MATLAB or Python, you know, you have train DX, learning DGM, and other gradient learning methods, and many other learning methods which you can apply. And you can calculate like these 0.5, 0.9, 0.3 is there, and in the hidden layer you are having, say, these weights. 1 minus 2 2 minus plus 1 minus 4, like this. So these hidden layers are having the weight. So if you see h1, so if I say h1 means here this one is here, this minus 2 part is here. Where is that? Yeah, minus 2 is here, and 2 is here. Similarly, H2 is having this here. I have not written it in this because you'll be confused. So I'm just scrolling it here. Then 1 is here. Here it is minus 1. And this is 0. 0 means there is no connection actually. 0 means ye cut gaya line. Similarly, this output also is having like this. So output 2 में जैसे ये वाला line कटा हुआ है. So what is happening here is the weight set that you are having, the same kind of thing happens. So here, as this is 0, so this is cut. So you have 1 here, और यहाँ पे 2 है weight, और here it is minus 3, and you have 1, and you have minus 3 here. So like this you can calculate. Now you don't have to calculate one by one. Now these things your programs will calculate. So the next stage is calculated 0.13, 0.96, 0.4 हो गया. Then you can apply again. So again, next stage you will be doing this kind of calculations, and you can get what is the sigmoidal output. Okay, you take the output of these three outputs are calculated based on the weights, and once you get the weights here, these are calculated. So I had initially started off with NOT gate, AND gate, OR gate, and now I am going to more complicated problems. Like this is coming from here, ये इधर से आया है. I hope it is you are getting it what I am trying to do here. So like this, if in machine learning more and more neurons come, you will have more and more kind of, and see after that in the अभी output layer का भी calculate हो गया 0.35 or 0.85. Here you are applying the sigmoidal function. It is not a simple thresholding function. Okay, so like this you have the calculations being done. So 0.35 and 0.85 is coming here.
Sir, weights are taken randomly.
Yeah, weights are taking. Yeah, weights I am taking randomly. You can put any other weight. Just is just a calculation. I'm just showing you the calculation, nothing else. Okay, you can take any weight, and you can apply some matrix kind of multiplication also. You take the hidden layer, take the input, multiply, and S is the sigmoidal function, and in the hidden layer this output will come. एक एक करके, you don't have to do the calculation, you can do matrix multiplications here and it will give you the output. Okay, so when you train, what happens is you perform some inference on the training set, you calculate the error between the prediction and the actual labels of the training data, then you determine what is the contribution of each neuron in the error. It is something like वो इंडियन टीम में 11 प्लेयर खेल रहा है, अरे उसने बैटिंग अच्छा से नहीं किया, इसने बॉलिंग अच्छा से नहीं किया, वो वाला बॉल में प्रॉब्लम हो गया. सो दोज थिंग्स आर देयर. What happens, it is normally Indian team koi bhi if it loses any match, what we say, are today Virat Kohli should have performed. Now our expectation from Virat Kohli is more compared to somebody else. So what we do is that we give more weight to him. So when you give, in yesteryears we used to give more preference to Sachin Tendulkar. If some unknown player is not making good score, we will not blame him much. We'll blame the captain. Why did he take him? And if a known player is not making good runs, say our opening pair is not good, our this is not good, that is not good, means in the back of the mind we are assigning some weights to all the players. Now if Bumrah doesn't get good number of wickets, we'll say, but if we take a newbie and he doesn't get wickets, okay, he's a new player, he didn't get wicket because he's not the experienced one. So that is what happens in the neural networks also. The one which is having more weights, if that one is making some mistake or less prediction or any error in the prediction, it is creating the problem. Okay. So that issue is there, and like this, the system has to get trained again and again. There may be some, whether it is supervised, unsupervised, or your reinforcement, whatever way. Whether it is, if it is supervised, there will be some target output based on which it will be trained. There may be some clustering. There may be some credit blame systems based on which the system will learn. So you have the error contributions coming, and they are, if it is the normal backpropagation algorithm, you'll be applying that. There may be different gradient descent algorithms where you can have these. Okay, so in backpropagation, what you have is which weight is to be updated by how much. So there you have to define which weight is to be blamed. Virat Kohli के अंडर मैच नहीं जीत रहा है, so you don't want to have him as captain. So that is the basic idea. So there you can assign a blame. Now Rohit Sharma is winning more matches as a okay. So here you see the back propagation is there. So here what we put, here we put a new term. Here we have this del E by del W. Del E stands for the error and del W is the rate of change with respect to weight. So with respect to different weights, what is the amount of error? Okay, so that you calculate. So our basic idea is to reduce the rate of change of error as much as possible. If the error is fixed, that 0.001 is the error that is allowed, I know that this error is fixed error. So that there should be no change in error. If I am able to know that the ground truth that this much target is 0.9 should be the output and I get 0.35. So I do what? 0.35 minus 0.9. Whatever is the error, I have to incorporate it as a output minus target or ground truth. And based on that, new change of weights will be there. So as there are different algorithms of changing the weight, gradient descent is one of the popular ones. So it minimizes the neural network's error. So in every step, the error is calculated on the training data and the weights are changed again and again. So this terminates in two cases. One case when the error is sufficiently small, say we say that we can allow error up to 0.001. So once the error reaches 0.001, this training stops. Or we say that we'll iterate it or there will be 6 epochs or 5 epochs, or this is the number of iterations that we'll do. After that, training हुआ तो हुआ, नहीं हुआ तो नहीं हुआ, समझ में आया तो आया, नहीं आया तो नहीं आया, this kind of thing also may be there. So in both cases, we'll terminate. So this is just the same which happens in now the big shot is the convolution neural network. For hardware point of view, they are using the spiking neural network. I'm not going to that. Okay, so you have this kind of output calculations. You can do pooling also. Like here, you see, for if I do 2x2 max pooling, so here this is the max, and here this is both are max. So you can take any one of them. Means I'm taking this and taking 2. I'm taking this and taking 3. I'm taking this, and the maximum value is 3. And here I'm taking this, and I'm taking. So this is the basic idea which can be used in algorithms like image compression or so on. Deep learning, I'll just give you an overview. It is already 134. Sir had asked me to go up to 145 maximum. So I'll just give a brief overview on the deep learning part. I think when Bhuya sir is taking up computer vision, he will definitely touch deep learning. So I'm not going much into details of that. Basically, deep learning, what you do in machine learning, we are having inputs coming. We calculate the features, and then we have the neural network. Whereas in deep learning, what you do, you increase the number of inputs and you avoid this feature extraction. So for feature extraction, you have more layers. So that is the basic difference between deep learning and machine learning. And what happens is that that is the reason why when I put the Venn diagram, I had put deep learning as a subset of machine learning. Okay, so you have the feature extraction going on in the neurons. So it is much easy to handle deep learning, but you need more computation power. You need GPUs to do that set of processing, as well as because you are avoiding one part of this feature extraction part. So you need more neurons to handle that feature extraction part. Earlier you were doing the feature extraction. Now, if you do a wrong feature extraction, what will happen? Then you don't get a proper output. Now here that in deep learning you lose out more control because the feature extraction part is also out of your control. You have given that also work to your. It is something like we have somebody for handling only say the cooking and washing of utensils and cleaning the room. Now you ask him or her to do some other extra jobs, assignment kar do and any other things. So you are putting more and more stress on the neural network and reducing your work. You are using inbuilt algorithms and going ahead. Okay. So basically here in machine learning, you are doing feature extraction and telling that whether it is a cat or not. And if you apply deep learning, you will say not only what cat it is, you'll see the breed of the cat and other things. Okay. So this slide I'm taken from MATLAB. You can see that. And there are various kinds of things for deep learning. You are having you have different classifiers. Like say for example, this is a car. So here we have a handcrafted feature extractor which we are doing in machine learning. But here what you'll do, you'll have trainable feature extractor is available like GoogleNet, AlexNet. These are there. So you can directly call them and do. One of my PhD scholars, Dr. Ajit, who was working, I had told you earlier, on this ECG and PCG based heart abnormality analysis. What he did, PCG is a one-dimension signal, ECG is one-dimension signal. So just to use deep learning, what he did is that he converted the one-dimension ECG signal or one-dimension PCG signal to two-dimension via the scalable wavelet features. And by converting into two-dimension, he could directly apply deep learning. Otherwise, normally, unless the ECG is in image format, you cannot apply deep learning. So what he did, he converted the one-dimension ECG signal, ECG data, to two-dimension, or the PCG data to two-dimension, and he applied deep learning. Because unless you convert it to two-dimension, it is not in image format. And if it is not in image format, you cannot apply the standard algorithms of GoogleNet, AlexNet, and other things which are available in Python, MATLAB, or any other format in GitHub. So he used that and he configured the different VGG and other SqueezeNet and other thing configuration parameters based on his features, and he has applied that accordingly. Okay. So I'm not going ahead much here. I think it is better to stop here because my slides, more slides are there. I'm not going to that. I think deep learning sir will be taking it up. So up to AI and ML introduction part, I think if you have any problem, you can tell me. I'm there. You have any clarifications about the machine learning or AI part? Any of you?
Sir, what is the difference between that AI and machine learning? How can you?
See, AI is artificial intelligence. It can be any artificial intelligence, may be via any set of programs. But if I say fuzzy logic, sir, are you aware of fuzzy logic, or should I just give a brief idea?
Slightly.
Yeah, so in fuzzy logic, what happens here? We try to have the idea how a human identifies the things. Like instead of saying directly 0 and 1, we say maybe yes, maybe no, certainly yes, certainly no, kind of things. We are bringing those things. So here the human behavior is brought into the programming, or in expert systems what we are trying to do. If a boiler is there, the boiler, if olden days boiler, not the present SCADA based systems and other things, DCS and PLC systems are there in the present day system. If I have a old say boiler, there the boiler temperature is controlled via various things, like the flow of the fuel, then the how the cooling of the coolant flow in the boiler boundary and other things. So you have various parameters. So if a skilled worker is there, so he knows which parameter to change and which thing to do and other things. So what we are doing in expert system is that we are trying into bring his knowledge into a machine program based thing, and then we are trying to apply that. So there what we are doing, we are having a machine or to do the work of a human being, or a rather a experienced human being, not a normal human being. So we are trying to incorporate, because that experienced person will be retired. So once he is retired, we cannot get his expertise every time. So we are trying to bring in a system which can emulate that person and help in doing the job. So even in natural language processing, we can do natural language understanding, natural language doing, then you have robotics and many other things. So when I say AI, I mean everything, means it can be any machine that is working. It is not necessary that it has to be neuron based machine. Fuzzy logic is also there, AI based optimization techniques are also there, everything will be there. But when I say machine learning, means we are having neural networks, and they will be following some algorithms, and based on the features they will learn and they will work. So when it is only based on neurons, some algorithms which are applied in the neural learning pattern and includes being features, it is machine learning. And when we have in general anything where the machines are being programmed in different ways to do our job, that is your artificial intelligence, because we are programming the machines in a way where we can replace them with something like human intelligence. Means we are giving some intellect to them. Is it clear, sir?
Yes, sir. Yes, sir.
Okay. So anything else? Anything else?
I think, sir, there is no query.
Okay, so actually I have let's say so I'm sharing my screen. If
Sir,
yeah, tell me.
can you say PPT?
Yeah, sure. I'll send it to Kalyan sir. I think he can circulate.
Okay, sir.
Kalyan sir.
is it almost complete, no, sir?
Yes, actually, I didn't complete the whole set of slides. I didn't want to go to the deep learning much. Otherwise, there will be overlap between my lecture and what this sir will be taking up. Bhuya sir will be taking up post lunch.
Right, sir, right.
So I didn't want to overlap with him because the deep learning part is more where. So I have mainly taken up the AI part and machine learning part, and I think sir will be again continuing with machine learning and going to deep learning.
Yes, sir, yes, sir. So thank you, sir,
Thank you.
for delivering your valuable lectures. So in near future, sir, I would like to expect your active participation with our any type of program, sir, related to our maybe faculty development program, maybe short-term course, or maybe webinar. So, sir, we are expect your active participation, sir.
Thank you. Thank you very much.
Sir.
We'll also be trying to, because ours is a central university, so our problem is that we don't have too many engineering departments. We have around six, though 44 departments, but mainly engineering we have six only. So and very less number of faculty members, so we can use your expertise also. We are having electronics, computer, IT, electrical, all four departments we are
Actually,
having.
sir, NIT Manipur is not a big institute, sir. It is also a small institute.
We are having many departments, but number of faculty members are less, so that is the main issue. In my department, 3 or 4 faculty positions are vacant, and other departments also the same thing. We have 2, 3 faculties in each and every department. The only good thing is that we are running PG. We are not having UG, so that is the blessing in disguise. Affiliated colleges are running the UG programs.
Okay, sir. Okay. Thank you, sir.
Thank you.
Thank you all. So, dear participants, so we will be back shortly. So next session, there is a third session. We should start sharp 2:30 p.m. So please stay with us. We will be back.
Thank you, sir.
Good afternoon, dear all participants, respected speaker. So, Professor Manoj Kumar Bhuyan, already he's joined now. So, we shall start shortly our next session, session 3, in FDP program organized by Department of Electronics and Communication Engineering, NIT Manipur, and sponsored by AICT, ATAL Academy. So, sir, Manoj Kumar Bhuyan, sir, are you audible? Am I audible, sir? Okay,
Yes,
sir.
yes,
Yes,
you're
sir.
audible. Yes, audible. Yes,
So, with your permission, sir, can I start, sir?
yes, yes. We can
Okay,
start.
okay, ma'am, over to you. Please start.
So, Professor Manas Kamal Bhuyan received his PhD degree in Electronics and Communication Engineering from IIT Guwahati. He was with the School of Information Technology and Electrical Engineering, University of Queensland, Australia, where he was involved in postdoctoral research. Subsequently, he was a researcher with the Safe Sensor Research Group, NICTA, Brisbane, Australia. He was an assistant professor with the Department of Electrical Engineering, IIT Roorkee, and the Johor Engineering College, Assam, and he also worked in Indian Engineering Service. In the year 2014, he was a visiting professor at Indiana University and Purdue University, Indiana in USA. Dr. Bhuyan was a recipient of a National Award for Best Applied Research and Technological Innovation, which was presented by the Honorable President of India in the year 2012, and the prestigious Fulbright Nehru Academic and Professional Excellence Fellowship and the Boy Scouts Fellowship. He is an IEEE senior member. He is currently a professor with the Department of Electronics and Electrical Engineering, IIT Guwahati, and Associate Dean of Infrastructure Planning Management, IIT Guwahati. He is also currently working as a visiting professor, Department of Computer Science, Chubu University, Japan. His current research interests include machine learning and artificial intelligence, image video processing, computer vision, human-computer interaction, virtual reality, augmented reality, and biomedical signal processing. He has almost 27 years of industry teaching and research experience. He is the author of the textbook Computer Vision and Image Processing Fundamentals and Applications, published by CRC Press USA in the year 2019. Over to you, Professor.
Okay. Okay, thank you for your introduction. So I'll start my talk. Am I audible?
Yes, sir. Yes, sir. You are audible, sir.
Okay. Okay, so I'll put up my video now. And I am sharing my PPT. Okay, is my screen visible now?
Yes, sir. Yes, sir. It is visible.
Okay. Okay, welcome to this the Faculty Development Program FDP, organized by NIT Manipur. So today my topic is Introduction to Machine and Deep Learning and Applications to Computer Vision. So mainly I will discuss one application, that is gesture recognition. So application to computer vision, and one application specifically I will give importance, that is gesture recognition. So first I will explain the fundamental concept of machine learning. So what is machine learning? And after this, the concept of deep learnings. And after this, I will explain the concept of computer vision and the applications of computer vision. So this is my plan of today's talk. So the content of this lecture is, the first I will introduce the concept of computer vision, image processing, and computer graphics. After this, briefly I will introduce the concept of machine learning. After this, I will explain the concept of deep learning and the gesture recognition, that is one application of computer vision. So that also I will explain. And after this, I will show some of the videos, what we are doing, the research. So some of the applications I will discuss. So this is the outline of my talk. So I request all the participants to mute your microphone, because otherwise it is very disturbing. So just please mute your microphone. After this, during the interaction session, no? So we can discuss. So if you have any questions, then we can discuss during the interaction session. Otherwise, please mute your microphone. So research areas mainly. Is it one participant sent one message? There is a problem in the network. Is this the PPT is visible and my voice is audible?
Yes, sir. From my side, it is visible and also audible, sir. But
Okay.
maybe different from different state in our country, they are joining.
Okay.
So maybe problem.
Okay. So my research areas mainly I will discuss. These are my research area. One is image and video processing. Another one is computer vision, machine learning, and the deep learning. And finally, one application, and that is human-computer interactions. So these are my research areas. So what is computer vision? So that is the definition I want to explain. What is computer vision? Building machines that see. So I can say it is a complement of biological vision. In biological vision, we have eyes. We can see objects. We can see images. We can see videos. And after this, we do some processing in our brain. And finally, we can recognize. That is the biological vision, the human visual system. So computer vision, I can say it is a complement of biological vision. So that the machine can interact with the world, or maybe the input to the computer vision system is images and the video, and output is nothing but the interpretation of the images, the interpretation of the videos. So I can say it is the modeling of biological perception. So the computer vision is nothing but the complement of biological vision. I can say like this. So if you see these two block diagrams, one is the human visual system, another one is the computer vision system. In human visual system, you can see we have two eyes. We can see objects, we can see images, we can see videos. And after this, we do some processing in our brain. And after this, we take intelligent decisions. We can recognize objects, we can recognize videos, we can recognize face, we can recognize images. So that any intelligent decision we can take. In case of the computer vision, we have camera. maybe single camera or maybe multiple cameras for image acquisition, for video acquisition. After this, we do image processing, that is the pre-processing we have to do. And finally, we have to apply the machine learning or the artificial intelligence algorithm for decision making. This pattern recognition is the machine learning and the artificial intelligence algorithms for decision making. So if you compare these two block diagrams, they are very identical, very similar. One is the human visual system, another one is the computer vision system. So they are very similar. So the cameras are available for image and the video acquisitions, maybe multiple cameras or maybe single camera. After this, we have to do the processing, that is the image pre-processing. And finally, we have to apply the machine learning and the AI algorithms for decision making. So one is the human visual system, another one is the computer vision system. So now you can see the distinction between the computer vision, image processing, and computer graphics. In computer vision, the input is images or the video, and output is the interpretation of the image, the interpretation of the video. So that is the definition of computer vision. So I can say it is image analysis, image interpretations, scene understanding. So input is image and output is the interpretation of the image, interpretation of the video. In image processing, the input is image and output is also image. So suppose if I want to improve the visual quality of an image, I have to do image processing. Suppose if I want to remove noises in an image, then I have to do the image processing. So in that case, my input is image and output is also image. So similarly, if I want to improve the visual quality of the image, suppose if I want to improve the brightness or if I want to improve the contrast of an image, I have to do the image processing. That is input is image and output is also image. So these are some examples like image recovery, image reconstruction, image filtering, image compression, image visualization. That is the definition of image processing. In computer graphics, the input is a model. So any model we can consider, and from the model I have to generate the image. So I can generate the image. I consider suppose the model of a tree. So from this I have to generate the image of a tree I can generate. So you can see the distinction between computer vision and the computer graphics and also the image processing. So there are many applications of computer vision. You can see these are the applications. So maybe in multimedia there are many applications. In video surveillance, also one applications. In biomedical image processing, medical image processing, visual navigations, augmented realities, optical character recognition, or maybe the 3D reconstructions, and virtual games, 3D object recognition, or maybe the image segmentation, human-computer interactions, inspection of the industrial components, robotics and the automation. So there are many applications of computer visions. So these are some of the applications. And one application is very important, that is the biomedical image analysis. So that point I will explain later on. So what is biomedical image analysis? So for computer vision, that is the image analysis, if you can see this block diagram, the input is the image, and after this we have to do some pre-processing, that is the image pre-processing we have to do. So maybe we can improve the visual quality of an image, and also we can do the segmentation. Segmentation means the partitioning of an image into connected homogeneous region. So maybe we can separate the foreground from the background. So like this we have to do the image segmentation. After this we have to consider the features, because final is basically the image analysis. So for image analysis we have to extract some features. This is the mathematical description of a feature. So here I have shown one feature vector. X is a feature vector, x1, x2, these are the elements of a feature vector. So we have to extract the features from the input image, and based on this feature, all these features, we have to do the classification. So suppose in a medical image, we may consider some tumors. So detection of the tumors, or it may be the malignant tumor or maybe the benign tumor. So that also we can determine, that also we can recognize based on this system. That is the system is the machine learning system and the computer vision system. So this is a typical block diagram of an image analysis system. So now what is actually the artificial intelligence, what is machine learning, and what is the deep learning? So artificial intelligence means the programs with the ability to learn and reason like humans. So this is a broad area, the artificial intelligence. And if you see the machine learning is a subset of artificial intelligence. This is very popular, the machine learning. And mainly we will consider the statistical machine learning techniques and also the subcomputing based machine learning techniques. Maybe we can apply the artificial neural networks, the fuzzy logic we can apply, genetic algorithms, genetic programming. So these type of algorithms we can apply in machine learning. And deep learning is one subset of machine learning. So mainly it is the advanced version of artificial neural network. In artificial neural networks, there are some disadvantages. So to eliminate these disadvantages, we may consider the deep learning techniques. So deep learning is a subset of machine learning. So some of the machine perceptions like the speech recognition, fingerprint identification, optical character recognition, DNA sequence identification, biomedical image processing, biomedical signal processing. So these are some applications. And in this case, we can apply the machine learning. The machine perception is quite important in these cases. So this is a typical block diagram of a machine learning system. So we have the patterns. So we have to do some measurement. Measurement means we have to extract features. So we are getting the measured value, and this is called a feature extraction. After this, all the features may not be useful in a particular application. So that is why the feature selection is quite important. So we have to consider the most discriminative features, most informative features that we have to extract. So that is why the feature selection is quite important. And after this, I am getting the feature vector. The feature vector is X. And after this, I can apply the classification. The classification is this. So for the classification, we have the database and the rules, and we can do the classifications. That is the decision making. So there may be two decisions. One is the hard decision, another one is the soft decision. In hard decision, if you consider the decision boundary between the classes, it is very rigid. But in case of the please mute your microphones. And in case of the soft decisions, the decision boundary is not so fixed, not rigid.
Sir,
So there is a
sorry disturb you, sir. Pooja Thakur, dear participant Pooja Thakur, please mute your mic. Don't disturb. Pooja Thakur, is it audible? Please mute your mic. Please mute your microphone. It is very disturbing.
Please.
Okay, sir.
Okay. So in case of the fuzzy decision, there is a possibility that a particular sample corresponding to a particular class may belong to another class. There is a possibility. So maybe one sample corresponding to a particular class may belong to another class. There is a possibility, and that possibility is determined by the membership grade. So one decision is the hard decision, another one is the soft decision. That's a fuzzy decision. And here I have shown the concept of the pattern classification. What is the pattern classification? So I am considering three classes, Wi, Wj, Wk. So first I am considering the class membership space, that is C. And after this I am showing the pattern space. The patterns are P1, P2, P3, P4. These are the patterns. So corresponding to the class Wi, I have two patterns. So one is P1, another one is P4. Corresponding to the class Wj, I have the pattern is P2. And corresponding to the class Wk, the pattern is P3. So this is the pattern space. And you can see the patterns are overlapping. So what is the meaning of this? That means this pattern may share a common attributes. These patterns may share a common attributes, so that is why it is overlapping. And corresponding to all these patterns, I have the measurement. The measurement value is M1, M2, and M3 in the measurement space. So M1 corresponding to the patterns P1 and P3. Corresponding to the pattern P2, I have the measurement M2. And corresponding to the pattern P4, I have the measurement M3. So I have the measurement. Now, what is the pattern classification problem? The pattern classification problem is from the given measurement, I have to determine the corresponding class. So suppose M1 is available. So corresponding to M1, what is the corresponding class that I have to determine? So this is the concept of the pattern classification. And you can see it is not one-to-one mapping. It is not one-to-one mapping. So had it been one-to-one mapping, the pattern classification problem would have been very, very easy. But it is not one-to-one mapping. So from the measurement, I have to determine the classes. So that is why the pattern classification problem is difficult, because it is not one-to-one mapping. So from the measurement, I have to determine the corresponding class. So underlying class, so I have to determine. So that is the concept of the pattern classification. Now mathematically, this problem I can show like this. The probability of Wj is the class, given x is the Fisher vector. So the measurement is available, and corresponding to this measurement, I have to determine the class. So that probability I have to determine. This is the concept of the pattern classification. Okay. So Fisher vector is available. X is the Fisher vector. And from the Fisher vector, I have to determine the corresponding class. That probability I have to determine. So this is the concept of the pattern classification. And one pattern classification is the syntactic pattern classification. This is the syntactic pattern classification. That is nothing but the description of a particular pattern. So suppose if I consider A, so I can consider A as these two lines and one horizontal lines, two diagonal lines and one horizontal lines. So with the help of this primitive, I can represent the letter A. But nowadays, these syntactic pattern classification techniques, they are not much of use. They are not used. They are not popular. The popular is the statistical machine learning. That is very, very popular. So this is not so popular. So the components of a pattern classification system, so already I have explained. So the patterns are available. So we have to take some measurement. So that is why the sensors are available, and we have to do the pre-processing. After this, the Fisher extraction, we have to do Fisher extraction, and the classification also we have to do. And we are considering the supervised learning. So we have the learning algorithms. So I will explain what is supervised and what is unsupervised. So we have the learning algorithms, and after this we can take a classification decision we can take. So that is a class assignment, means the decision we can take. So this is a typical PR system, the pattern recognition system. So I can give one example here. Suppose these two persons, the name of the person is jockey and the hoopster recognition. So one is, in this case, how to recognize. So we are considering two features. One is, suppose the weight, another one is the height. These two features we are considering, the height and the weight. And based on this, I want to recognize these two persons. One is the jockey and another one is the hoopster. So the Fisher vector X has two components, X1 and X2. So X1 corresponds to height, X2 corresponds to weight. So based on this Fisher vector, I can take a classification decision. So I have the training samples. The training samples are available, X1, Y1, X2, Y2. So like this, I have the training samples are available. And with the help of the training samples, I have to do the training of the model. And I am considering a linear classifier. So I have two classes. One is H, another one is J. So you can see the decision boundary between the two classes. One is the blue, another one is the red. So two classes are available. And I am considering one decision function. The decision function is w.x. That is the vector dot product. W.x means the vector product dot product. Plus B is the bias. Greater than equal to 0. If this condition is satisfied, then the class is H. If w.x plus b is less than 0, then the corresponding class is J. So based on this function, the linear function, I can do the classification. So what is the equation of the decision boundary? The equation of the decision boundary is w dot x plus b is equal to 0. So that is the equation of the decision boundary. So this is one example of a simple classification technique. And already I have explained the concept of the feature selection. So I have to extract the most discriminative features, most informative features. So that is why the good features are quite important. So in the first example, you can see I can easily draw a decision boundary between the classes. One is the red class, another one is the blue class. So I can draw a decision boundary between the classes. So that is one example of good features. In the second case, if you see, it is very difficult to draw a decision boundary between the classes. You cannot draw a simple decision boundary between the classes. So the second one example is the bad features. So that is why the feature selection is quite important. So this is the feature extraction method. So we have to extract the features. So you can see the feature vector x1, x2. These are the features. So I am considering the feature vector is suppose x. So x1, x2, xn, these are the elements of a feature vector. And after this, I have to reduce the dimension of the feature vector. So I can reduce the dimension of the feature vector because all the features may not be important. So I have to select the most discriminative features. So in a pattern classification problem, if you select many features, that is not a good idea. Suppose you have a limited number of training samples. If you select the more and more if you select more and more features, that will not improve your accuracy, the recognition accuracy. It will degrade the recognition accuracy. And that is called a curse of dimensionality. That is called a curse of dimensionality. So better not to select many features for a particular pattern classification problem. So you have to select the most discriminative features. And there are many techniques for feature selection. One very common technique is the PCA, the principal component analysis. So I'm not going to explain the concept of the PCA. So this is one simple example, but there are many algorithms for dimension reduction. You can reduce the dimension of the feature vector. So here I have shown the decision boundary between the classes. So the regions, the feature space I have shown, x1, x2, x3. These are the regions. So feature space. So x1 corresponds to the class w1, x2 corresponds to the class w2, x3 corresponds to the class w3. In the first case, I am showing the linear decision boundary. In the second case, I am showing a non-linear decision boundary between the classes. So x1, x2, x3, these are the regions corresponding to the class w1, w2, w3. And for pattern classification, in statistical pattern classification technique, we consider one function, and that is called the discriminant function. So discriminant function is represented by GIX. That is the discriminant function. So for C number of classes, I have C number of discriminant function, Z1x, Z2x, ZCX like this. So C number of discriminant function. So input is the feature vector, and I have to determine the value of the discriminant function Z1x, Z2x, Z3x like this I have to determine. And the maximum discriminant function we have to determine, we have to consider. And based on this, the corresponding class I can easily identify. Suppose the Z2 is maximum, then the corresponding class is W2. So like this, based on the discriminant function, I can do the classification. So for a classification technique in statistical techniques, I have to determine the discriminant function Z1, Z2, Z3 like this I have to determine. And the maximum discriminant function I can easily determine. And from this I can determine the corresponding class. Okay. So this is the representation of classifier. In case of the Bayesian decision theory, that is the statistical learning techniques, we are considering these two popular techniques. One is the risks and another one is the classification error. So the risks of taking a particular decision that we can consider, or maybe the probability of error we can determine. So based on these two parameters, I can take a particular classification decision I can take. So I can say I can take the probability of error I can determine mathematically. I can determine the risks of taking a particular decision I can take, and based on this I can take a classification decision I can take. And these are some terminology for statistical machine learning. So one is the classes. The classes are represented by W1, W2, W3 like this. So in this example, I am considering the classification problem, classification of two types of fishes. One is the sea bass, another one is the salmon. So these two fishes we are considering. One is the sea bass, another one is the salmon. So W1 is the class is that is the sea bass. Another one is the salmon. The salmon is W2. And the prior probabilities are P, W1, P. Rule. The probability of Wj given X is equal to probability of X given Wj into probability of Wj divided by probability of X. So because the pattern classification problem, we have to determine the probability of Wj given X. That I have to determine. So with the help of the information, the likelihood and the prior, I can determine that information. The information is the probability of Wj given X. Evidence has no importance because it is a normalizing factor. It is a simple normalizing factor, so we need not consider the normalizing factor. And you can see the decision rules. We can consider W1 if the probability of W1 given X is greater than probability of W2 given X. Otherwise, I have to decide W2. So you can see all the decision rules based on this, the base rule. So with the help of the likelihood means the probability of X given Wj. That is very important. The feature, probability of X is the feature given the class, particular class. So that information is available. So with the help of this information, I can determine probability of Wj given X. That is the pattern classification problem. So in a pattern classification problem, I have the training samples, I have the testing samples. So these algorithms for recognizing unknown test sample. So first I have to do the training, and after training I will be getting the train model I will be getting, and after this I have to give the input. That input is the test samples are inputs, and corresponding to this I can do the classification. I can recognize the test samples. Okay. And here I am considering the supervised learning. So supervised learning, if you see what is the concept of the supervised learning. So that means this supervised learning means corresponding to each every classes, I have the training samples. So corresponding to the class W1, I have the training data set. The data set is D1, suppose. Corresponding to the class W2, I have the training data set D2. So D1 is for W1, D2 for W2, D3 is for W3, like this. So I have the training samples, the training data set for each and every classes. That is called the supervised. So within the training data set D1, I have the training samples. The training samples are X1, X2, X3. These are the training samples. Similarly, for the another data set D2, I have the training samples X1, X2, X3, like this. These are the training samples. So the supervised means that is available. And if you see the based rule here, that means the probability of X given Wj. The feature vectors are available corresponding to the particular class Wj. So that means the supervised, this is the supervised. That is available, the probability of X given Wj. That is the supervised, because for each and every classes, I have the training data set. Training samples are available. So this is the supervised learning. So one example I can give. So suppose I want to recognize 26 alphabets, uppercase. So first I have to collect the samples. These are the training samples. First I have to do the training. So I'll be getting the train model. And after getting the train model, I have to give the unknown alphabets for the testing. So first I have to do the training, and after this I have to do the testing. And I can give some examples of the pattern like fingerprint image, handwritten words, human face, speech signal, DNA sequence, alphabet, like this. These are some examples of the patterns. This is one example, the handwriting recognition. So we can apply the machine learning techniques. This is the face recognition problem. so we can recognize faces. So this is one example. The fingerprint recognition. So you can see different fingerprints. So we can recognize different fingerprints. The space of machine learning methods. So what are the machine learning popular methods? I will explain. So what are the methods? So already I have explained the concept of the supervised learning. So first I have to do the training with the help of the training samples. So for each and every classes, we have the training data set, that is the supervised. And after this, I am getting the train model, I am getting the learn model, and with the help of the learn model, I can do the testing. So here you can see, first I am doing the training. So level data is available, and machine learning algorithms we are considering, and we are getting the learn model. So after getting the learn model, that is the train model, I can apply the level data, that is, I can apply the level data, that is for the prediction. And after this, I can do the prediction, that is the testing. So I can do this one. First I have to do the training, and after this I have to do the testing. So this is one example of the classification of A and B. So this is, I have shown the first one is the classification. And supervised already I have explained. Unsupervised later on I will explain. Unsupervised means the clustering. So I can do the clustering of the samples. So I can explain right now. So what is unsupervised? In unsupervised, the Fisher vector is available, only Fisher vector. X is the Fisher vector. So all the Fisher vectors are available, and I have to group the Fisher vector based on some similarity. So based on some similarity, I can do the grouping. So that is called the clustering. That is called the unsupervised. And the concept of the reinforcement learning, so I will explain later on. So what is the reinforcement learning? So first one is the classification. The regression is nothing but the fitting of a line or maybe fitting of curves between the sample points, the training samples. So sample points are available, and I can fit the line, I can fit a curve between the sample points. So which one is the best fit line and which one is the best fit curve, that I can determine with the help of regression. So already I have explained. So pattern recognition algorithms, we have first we have to do the training, and after this we have to do the testing. So mainly we are considering the statistical machine learning techniques. So this is one example. So how to select a features? Suppose one is the capital I, another one is the small I. So that means what feature I can consider to distinguish these two patterns. One is the capital I, another one is the small I. So suppose this dot above this bar, that I can consider as a feature. So based on this dot, I can do the classification. Because in case of this small I have a dot. For a capital I don't have a dot. So that is why the dot can be considered as a feature. So already I have explained. So the presence of dot. So this dot can be considered as a feature, and based on this we can do the classification. And this problem, the classification of the fish. So two fishes I am considering, two types of fishes. One is the sea bass, another one is the salmon. So for this, what we can consider? We can consider the features like the length of the fish, lightness of the fish, width of the fish, like this we can consider. So these features we can consider, and with the help of these features we can determine we can do the classification. So first I have to do the pre-processing. Pre-processing means I can do, because the images are available, the images of the fish are available, so I have to do the pre-processing. I have to do the segmentation. Segmentation means the partitioning of an image into connected homogeneous region. So that means the separation of the foreground from the background. So that I can consider. So first I have to do the pre-processing. After this I have to do the feature extraction. After this I have to do the classification. So two types of fishes we are considering, salmon and the sea bass. And first I am considering the length as a feature. So if I consider the length as a feature, you can see the classification, the count I am showing, the count is the classification accuracy. So there is some misclassification. The misclassification is shown by the red line. The salmon is recognized as sea bass, and sea bass is recognized as salmon. And in this case, we are considering only one feature. That one feature is the length. Length is one feature that we are considering. So in this case, the misclassification happening. So the sea bass is recognized as salmon, and salmon is recognized as sea bass. So that is why we have to consider another feature. So another feature we are considering, suppose the lightness of the piece. That I am considering, the lightness of the piece. So if I consider this feature, even in this case also there is a misclassification. So sometimes the C bus is recognized as salmon and the salmon is recognized as C bus. So misclassification happens. So to overcome this problem, I may consider these two features together. Together we can consider, one is the lightness of the piece, another one is the width of the piece, that together we can consider. And with the help of these two features, you can see I am showing the decision boundary between the classes. One is the salmon, another one is the sea bass. And I am showing the feature space. I have two features, one is the width, another one is the lightness. So that means we have to select the features, and one is the noisy feature we have to remove because we have to improve the performance. Performance means the accuracy of recognition. So you can see it is a non-linear decision boundary between the classes. The previous one is the linear decision boundary. This is a linear decision boundary between the classes. So that is also not good because the misclassification is happening here. You can see there is a misclassification sometimes. The salmon is recognized as sea bass and sea bass is recognized as salmon. So maybe we can consider this type of decision boundary, the non-linear decision boundary we can consider, and we'll be getting the optimal performance. So that we can consider. So again, I am showing the same thing, the pattern classification system. So the first one is the image acquisition. Next one is the segmentation, that is a pre-processing, feature extraction, classification, and the post-processing. So in the post-processing, we can determine the recognition rate, the computational complexity. So all these parameters we can determine. So one is the discriminative features. So we want the discriminative features. That is, the discriminative features should be invariant to affine transformation. The affine transformation means the translation, rotation, scaling like this. And also the classification accuracy should be good, very good. So this is one case, but the computational complexity is also another important point. So we have to see the computational complexity. So sometimes we have to compromise. We have to see the compromise between the accuracy and the computational complexity. So that we have to see. So same thing I am showing here, the collection of data, selection of the features, and selection of the model. After this, the training of the classifier, and after this, we have to evaluate the performance of the classifier. So this is the typical pattern classification system, the pattern recognition system. So training also we have to do, and after this, after the training, we have to do the testings. So this is this is already I have explained. This supervised concept and the unsupervised concept also I have explained. In supervised, we have the learned model. Sorry, we have the learned model means how to get the learned model. So corresponding to each and every classes, I have the training data set. So that is the label data set. That is the supervised. In case of the unsupervised, we have the feature vector and we have to do the grouping of the feature vector based on some similarity. That is unsupervised. So unsupervised is nothing but the clustering. So we have to do the clustering. So unsupervised means the grouping. So clustering is mainly the organizing data into classes. And for this, we have to consider the high inter-class similarity and low inter-class similarity. So this is important. So we have to see the high inter-class similarity and the low inter-class similarity. So based on this, we can do the clustering. That is the grouping. Grouping we can do. So here you can see I am showing some of the images. So you can see I am doing the grouping. First one is the family. One family I am considering. Another one is the grouping of the employee. Another one is the group of the females. Another one is the group of the males. So if you see these groupings, the clustering is subjective. So if I consider only the family, the group will be like this, like the first one. If I only consider the school employee, so it will be like the second one. If I consider the females, that will be in the third one. If I consider the males, that will be in the fourth one. So that is why the clustering is subjective. And already I have explained, so I have to find a similarity between the patterns. So maybe we can consider some distance, Euclidean distance, or maybe some other distances we can consider. So one distance is the Euclidean distance we can determine between the patterns. And based on this, I can find a similarity. So you can see, I can find a similarity between these two images, or if I consider these two words, I can find a similarity, or maybe between the fingerprints, I can find a similarity. And based on this, I can do the grouping. So one algorithm, very popular algorithm in machine learning is K-means clustering. So I think many of you know what is K-means clustering. So briefly, I will explain. So corresponding to the K-means clustering, what I have to consider, I have to initialize the K number of clusters, and that should be randomly. Randomly, I have to initialize the K number of clusters. And after this, I can show pictorially what is the meaning of this. So these are the samples. So first, randomly, I have to select the K number of clusters. So here I am considering K1, K2, K3. These are the cluster centroids. I am considering K1, K2, K3. And after this, what I have to consider, I have to find the distance between the clusters. I have to find the distance between the centroid and the sample points. Okay. So finding the distance, and after this, after finding the distance, based on the distance, you can see the green points are assigned to the cluster K1. The red points are assigned to the cluster K2. And these blue points are assigned to the cluster K3 because it corresponds to the minimum distance. So based on this, I can assign the sample points to the centroid K1, K2, K3. So this is the first initial grouping. After this grouping, the centroid will be changing. So I have to update the centroid. I have to recompute the centroid. So first I have to recompute the centroid. So I have to determine the new value of K1, the new value of K2, and the new value of K3. So I am finding the new value of K1, K2, and the K3. After finding the K1, K2, K3, this process I have to repeat again. The same process I have to repeat again. And I have to do the classification. So like this, again, you can see this green point is now assigned to red one. And similarly, this green point is assigned to now K3. So like this, I have to go for the assignment, the new assignment I have to go. And like this, again, I have to recompute the centroids, K1, K2, K3. And finally, I have to do this iteration repeatedly. And finally, no change of the centroid. So I will be getting the final centroid K1, K2, K3. And I will be getting the groups. One group is the K2, one is the K1, another one is the K3. So I can do the grouping like this. And these are some examples of the supervised and the unsupervised. Supervised because we have the training samples are available. So with the help of the training samples, we can get a learned model, we can get a trained model, and with the help of the predictive model, I can do the classification. In case of the unsupervised, we can consider the clustering, the groupings. That is the unsupervised learning. So one is the unsupervised learning. Again, I am showing the training data set is available. That means we have the Fisher vectors, and I have to group the Fisher vector based on some similarity. So based on the similarity, I can do the groupings. So these are my groupings. And sometimes it is very difficult to find a similarity. This is just for your interest. I am giving this example. So what is the similarity between these two? So you can see what is the similarity between these two.
Hello, sir.
Yes. Just I'm continuing. Yes. Just I'm waiting for some time. Yes. Okay.
Here, sir.
Okay. Am I audible now?
Yes.
Okay.
Yes, sir.
Okay. So these are some machine learning popular techniques. This is a supervised technique, unsupervised technique, and the reinforcement learning. So reinforcement I will explain later on. So some of the supervised, the popular techniques are regression, maybe the linear regression, polynomial regressions, decision trees, random forest, the classification like KNN. KNN is very popular, and the support vector machine. The support vector machine is also very popular. Logistic regression is also very popular. Naive Bayes is also very popular. Clustering techniques like singular value decomposition, the PCA, the principal component analysis, the K-means clustering. Like this, also we can consider the hidden Markov model. Hidden Markov model is very important for the dynamic data. So like this, we have these cases. And the reinforcement learning, I will explain. So one just algorithm I am explaining, not all the algorithm, it is not possible. The KNN. KNN is very interesting. So I am showing the KNN based clustering. So the two classes are available. One is the class A, another one is the class B. And suppose the new data point is available. So based on this distance, the minimum distance, I can assign this new data point to the class A, category A. So based on the distance, I can find which one is the nearest neighbor distance. So based on the distance, the nearest neighbor distance, I can assign this sample to a particular class. So like this, you can see the look at the data. In the first one, I have one data point that is the gray color. I can use a black color or gray color. And I have the three classes. One is the yellow, another one is the green, and another one is the orange. So first I am determining the distance between the sample and these samples. First distance is 2.1, 2.4, 3.1, 4.5. Like this, I am calculating the distance. So corresponding to this yellow sample, the distance is 2.1 and 2.4. So that is the first nearest neighbor and the second nearest neighbor. Corresponding to the 0.1, how many votes getting? Votes. How many votes? So yellow one is getting 2 votes, the green one is getting only 1 vote, and the orange one is getting only 1 vote. So based on this voting, I can assign this sample. The sample is the gray color sample to the class. The class is the yellow class. That is the K nearest neighbor algorithm. Very simple algorithm. So based on this, based on the voting, I have to assign this particular sample to a particular class. Again, the same thing I am showing. Initial data point is available. I have to determine the distances. All the distances I have to determine, and based on the distance, I have to determine the number of votes. And after this, I have to assign that sample, the initial data, to a particular class. So this is the simple K nearest neighbor technique. So other techniques like support vector machine, or maybe the PCA, the principal component analysis, the singular value decomposition, hidden Markov model, it is not possible to discuss in this lecture, 2 hours lectures. So one example I am giving here is the K nearest neighbor technique. We have already discussed the supervised and the unsupervised. In case of the reinforcement learning, suppose if I want to consider a particular problem, one particular action, that is the classification action, is not important. The group of actions are more important. That means the goal is more important. So I have to achieve the goal. So one particular action is not so important. The group of actions are more important. Corresponding to a good action, I will be getting a reward, and corresponding to a bad action, I will be getting a penalty. So I have to go for these actions, the number of actions, and I have to reach the goal. So I can give one example. Suppose the playing of a chess game. So one particular move is not so important. One particular move may not be very good. If the move is not good, I will be getting the penalty. If the move is very good, I will be getting a reward. But a group of moves are very important because our ultimate goal is to win the game. So that is why one particular action is not so important. The group of actions are more important. That is the fundamental concept of the reinforcement learning. So we have to determine which one is the best action, and corresponding to the good action, I will be getting a reward, and corresponding to a very bad action, I will not be getting a reward. So like this, I have to consider the group of actions to achieve the goal. So that is the concept of the reinforcement learning. And another one is a semi-supervised learning. So in a semi-supervised learning, we have only a small number of labeled data and a large amount of unlabeled data. So the meaning is small amount of labeled data is available and with a large amount of unlabeled data. The meaning is suppose in case of the biomedical image analysis, it is very difficult to get the label data. Suppose if I want to do the classification of the tumors of a suppose brain, it is very difficult to get the label data. So that is why typically a small amount of label data is available, only few label data is available, but the large amount of unlabeled data. For this type of applications, we can consider the semi-supervised clustering, semi-supervised learning. So we have only the small number of label data and large amount of unlabeled data. So it falls between the supervised and the unsupervised learning. So that is the concept of the semi-supervised learning. And regression, already I have explained, regression is nothing but the fitting of a line or fitting of a curve between the sample points. And this is a classifier, and you can see the decision boundary between the classes. One is the red class, another one is the green class. These two classes I have shown. And for this statistical machine learning techniques, one is the empirical risk minimization. So already I have explained, so we have to take a risk of taking a particular decision, and also we have to consider the probability of error. And no free lunch theorem is actually one particular pattern classification algorithm or machine learning algorithm may not be suitable for all the applications. Suppose in a particular application, suppose if I consider one biomedical application, so I am considering one classifier that is very good, but for another application that might not be good. So that means for all the applications, you cannot get a very good classifier. It depends on the applications. For a particular application, you can consider this classifier, maybe support vector machine you can consider. For another application, you may consider k-nearest neighbor technique or maybe some other techniques like this. So that is the concept of the no free lunch theorem. And in case of the classifier taxonomy, there are two types of classifier. One is the generative classifier, another one is the discriminative classifier. So generative classifier means, already I have explained, because to determine the probability of Wj given x, that is the posterior probability, I need the information. The information is probability of x given Wj. That is the likelihood. So that information I need. Okay. So that is called the class conditional density, the probability of x given Wj. If the density from is known, that density is known, the probability of x given Wj, that is the class conditional density, then this is called the parametric representation, the parametric from. That means the density from is known. The density means that it may be a Gaussian density, or maybe some other density, maybe some binomial distribution, or maybe some other distribution, the Poisson density, or like this we can consider. So suppose that the density from is known. In this case, I have to determine the parameters. Suppose if I consider a Gaussian distribution, in case of the Gaussian distribution, I have two parameters. One is the mean, another one is the variance. One is the mean, another one is the variance. So if I consider the multidimensional Gaussian, then I have the mean vector and the covariance matrix. So I have two parameters. One is the mean vector, another one is the covariance matrix. So that I have to determine. So in case of the parametric from, that means I know the density from, that is the class conditional density, the probability of x given Wj. So that information is available. So I have to determine the parameters. So in case of the Gaussian distribution, I have the mean vector and the covariance matrix I have to determine. So there are two popular techniques. One is the maximum likelihood estimation, another one is the Bayesian estimation. So by using these two techniques, I can determine the parameters of a distribution. One is the maximum likelihood estimation, another one is the Bayesian estimation. So these two techniques are almost same because they are giving almost similar results, but sometimes the Bayesian estimation gives better result as compared to maximum likelihood estimation. But the computational complexity of the Bayesian estimation is more as compared to maximum likelihood estimation. In case of the maximum likelihood estimation, we have to determine the partial derivatives. But in case of the Bayesian estimation, we have to consider the multidimensional integration. The multidimensional integration is very difficult to determine. So one popular technique is the Monte Carlo simulation. So with the help of the Monte Carlo simulation, we can determine that multidimensional integration. So these two techniques are very popular. You can see the books. One is the maximum likelihood estimation, another one is the Bayesian estimation. And another one is the non-parametric method. In case of the non-parametric method, the density from is not available. We do not know about the density from. So we have to estimate the density. So there are two popular techniques. One is called the Parjan window technique, Another one is the K nearest neighbor technique. So with the help of these two techniques, we can determine the density. So I am not explaining how to determine the density, but with the help of these two techniques, the Parjan window and the K nearest neighbor technique, we can determine the density. So this is about the classifier taxonomy. And another one that is about the generative classifier. In case of the discriminative classifier, that information is not even important. That is the density from. The density is not important. So without having this information, I want to find the best decision boundary between the classes so that it can separate the classes. So one is the generative classifier. In generative classifier, I need that information, that class conditional density. In case of the discriminative classifier, we do not need that information. That is the information of class conditional density. In case of the generative classifier, I have two types. One is the parametric, another one is the non-parametric. In parametric, I have to estimate the parameters. The density from is known. One is the maximum likelihood estimation technique, another one is the Bayesian technique. In non-parametric techniques, we have to estimate the density with the help of two popular techniques, the Parjan window technique or maybe the K nearest neighbor techniques. So in case of the discriminative classifier, that information is not important. That is the class conditional density. So we have to find the best decision boundary between the classes. So this concept already I have explained, the generative classifier, the probability density function, the class conditional density. Maybe we can consider the Gaussian density, Rayleigh density like this we can consider. And parametric classifier already we have explained. So these are the class conditional density. That information is available. Probability of X given W1, probability of X given W2, that information is available. And that is the concept of the generative classifier. And you can see the decision boundary between the classes. And non-parametric approach, the density from is not available, but we have to estimate the density. So for this, we may consider the techniques like Parjan window technique or maybe the K nearest neighbor technique. And in case of the discriminative classifier, so we do not have this information, the class conditional density, that is not important. So we have to find the best decision boundary between the classes. So discriminative classifier, what we have to consider, I can show the example. Examples like neural network, MLP is multi-layer perceptions, support vector machines like this. These are examples of the discriminative classifiers. So here you can see I want to find the best decision boundary between the classes. Okay. So first is the dotted line. First one is the rigid line. That is not good because you can see there are misclassification. So that is not the perfect line. But if you see the next line, the dotted line, that is the perfect line. So you can see the distinction between these two classes. One is 1, another one is 0. So I have to find the best decision boundary between the classes. So with the help of some techniques, so one popular technique is the gradient descent algorithm. So I have to update the weights or something like this. And based on this, I have to find the best decision boundary. So one example is the artificial neural network. One example is the support vector machine like this. We have to find the best decision boundary. That is the discriminative classifier. You can see this is the linearly separable data between the class. You can see one linear boundary between the classes. These are linearly separable data. And you can see these are linearly separable data and equations are like this. W1 is the weight. W1 x1 plus W2 x2 plus B is greater than 0. W1 x1 plus W2 x2 plus B is less than 0. So I have to find the weights. I have to determine the weights, W1, W2. I have to determine the weights. B is the bias so that I can get the best decision boundary between the classes. So this is the best decision boundary between the classes. So for this, I have to adjust the weights. The weights are W1, W2. These are the weights. And what is the equation of the decision boundary? The equation of the decision boundary is W1 x1, W2 x2 plus B is equal to 0. That is the decision of the. This is the equation of the decision boundary. This is the non-linearly separable data. So you can see, you cannot get one single decision boundary between the classes. That is the non-linearly separable data. So there are some techniques. So for this, one technique is this, the Kovar's theorem. So Kovar's theorem, in the next slide, I will explain what is the Kovar's theorem. What the meaning of this? The first figure, you can see, the samples are not linearly separable. So that is a two-dimension case. So if I project the data into high dimensional case, the data is projected into high dimension. So in this example, I am considering the projection from the two dimension to into 3 dimension. So in the 3 dimension, that is the high dimension, the samples are linearly separable. In low dimension, the samples are not linearly separable, but in the high dimension, it is linearly separable. So I have to do the projection. But in this case, it increases the computational complexity. So that is the concept of the Kovar's theorem. So I have to do the mapping from the low dimensional to the high dimensional. And for the pattern classification technique, there are some evaluation metric. Like this, we can determine the true positive, false negative, true negative, false negative, we can determine. And also we can determine the ROC, the region of convergence, we can determine. That is, ROC is basically the relationship between the TPR, the true positive rate, and the false positive rate. So that is, I can determine ROC. And also we can determine the confusion matrix. In case of the machine learning, we can determine the confusion matrix. So how many times 1 is recognized as 1? It is 137 times. How many times 2 is recognized as 2? 55 times. How many times 3 is recognized as 3? 84 times. So I can determine this. So this is the confusion matrix. And corresponding to this, you can determine the accuracy. Classification accuracy you can determine. You can determine also the error, the percentage of error you can determine. Like this you can determine. And the concept of the bias and the variance. So in the next slide, you can see what is the bias and the variance. Next slide I am showing. So first one, if you see, the first one is you can see the decision boundary between the classes. That is not a good decision boundary. The second one is the good compromise. That is one of the good decision boundary. But third one is the overfitting. Okay. So in case of the underfitting, that means the high bias, the error is maximum during the training and error is maximum during the testing also. That corresponds to high bias. And if I consider overfitting, that corresponds to high variance. During the training, the error is minimum, but during the testing, the error is maximum. That is also not good. So high bias is not good, high variance is not good. So we have to go for the good compromise. So you can see the good compromise. So during the testing and during the training, the error is moderate. It is not so high, it is not so low also. So that we have to consider the good compromise. That is the concept of the overfitting. So mainly we are considering this. We have discussed the types of machine learning, the supervised learning, unsupervised learning, semi-supervised learning, and the reinforcement learning. So up to this concept, I have discussed about this. Now I will discuss some of the concept that the bio-inspired computing, because I am going to the deep learning. So why the deep learning is important? So maybe we can consider the fuzzy logic, the artificial neural networks, genetic algorithms, or the genetic programmings. So why it is bio-inspired computing? Because the inspiration from the biologically motivated system, the motivations from the biology. So that is why it is called the bio-inspired computing. So the bio-inspired computing, so we may consider these algorithms, fuzzy logic, artificial neural networks, genetic algorithms, genetic programming. So I will only consider the neural networks. The fundamental concept of the neural network is mainly our nervous system, the human body, or maybe the nervous system of a biological organism, or maybe the human body we can consider. So here you can see we are considering the cell body and the dendrites. So they collect the signal from the cell body, and all the signals are sum up at a particular point. If the signal value is greater than a particular value, that signal is transmitted via axon. So here axon is available and the signal is transmitted. So this is the concept of the biological nervous system. So here again I am showing here, the left side is, you can see the nervous system, also right side is also the nervous system. The signals are collected by dendrites. The signals from the cell body. So it is collected by the dendrites and all the signals are sum up. And after this, if it is greater than a particular value, so we are considering the thresholding function, one thresholding function we are considering. If the value is greater than a particular value, then I will be getting one output, and that output is available in the axon. So I can transmit the signal via axon. So first the signal is collected, and after this it is sum up. If the sum signal is greater than a particular value, then I'll be getting a output in the axon. So that is the concept of the biological nervous system. So same system I am showing in the electrical system. So we are considering the signals S1, S2, S3, S4, S5. And I am considering the weights W1, W2, W3. These are the weights. So first the signal is multiplied by the weights. S1 is multiplied with W1. S2 is multiplied by W2 like this. And after this I have to do the summation. So summation is S1 W1 plus S2 W2 plus S3 W3. I have to do the summation. And if the sum value is greater than a particular threshold, so that threshold is defined by this activation function. So activation function is I am considering a squashing function. Squashing function we are considering. So if the sum value is greater than a particular value, the squashing function, then I will be getting the output. The output is S. S is the output I will be getting. So this is a squashing function we are considering. So squashing function is generally the sigmoid function. So this type of function we can consider. This is a sigmoid function. Sigma x is equal to 1 divided by 1 plus e to the power minus x. So this sigmoid function we can consider. In artificial neural network, we consider also the bias terminal. So what is the importance of the bias terminal? With the help of the bias terminal, you can move the sigmoid function along the right direction or along the left direction. So based on the value of the bias, we can move the signal along the right direction or along the left direction. So that is the concept of the bias. So this is one example of the squashing function. And in case of the fixed network, the weights of the networks are fixed. That is dw divided by dt is equal to 0. But in the adaptive network, dw divided by dt is not equal to 0. The weights we have to update. That means the knowledge of the artificial neural network is available in the terms of weight. So whenever we do the training, the knowledge is available in the weights. That is the concept of the adaptive networks. So that weight matrix is W. That is the collection of all the weights. The knowledge of the artificial neural network is available in the weights. That is the concept of the weights. And in this case also we have the supervised learning and the unsupervised learning. The concept is very similar in case of the artificial neural network. In supervised networks, we know what is the desired output corresponding to particular input. We know what is the desired output, and also we can determine the actual output. The difference between the desired output and the actual output is called the error. The error you can determine. The difference between the desired output and the actual output you can determine. That is the error. The error is back propagated to the input so that we can adjust the weights of the artificial neural network, and we can adjust the weights, and we can train the artificial neural network. That means we can change the weights of the artificial neural networks. And that is called the training of the artificial neural network. And this is the concept of the supervised, because we know what is the desired output. So that is why it is called the supervised. So corresponding to a particular input, we know what is the desired output. And that is the concept of the supervised. So supervised means we know what is the desired output. We can determine the actual output. The difference between these two is called the error. The error is back propagated to the input to adjust the weights of the artificial neural network. And like this, we have to do the training. And finally, the knowledge of the artificial neural network will be available in the weight matrix. That is the supervised. In unsupervised, also the same concept. We can do the clustering with the help of the artificial neural network. So there are some artificial neural networks like competitive learning, or maybe the coherent neural networks. So these type of networks we can consider for unsupervised clustering. So this is supervised, and unsupervised already I have explained. So this is a simple artificial neural network you can see here. So inputs, terminals are available, input nodes are available, x1, x2, x3, x4. Hidden layers are available, a1, a2, a3, a4. And you can see a1, 2, that is also another layer. And you can see the output. Output layer. In the output, you can get the output. Y, you can get the output. So this is a simple feed-forward network. And like this, you can see corresponding to this, I can determine the output. Output A1 I can determine. So I have to multiply the weights with the input W1 into X1, W2 into X2. Like this, I have to do the multiplication. And after this, I have to consider the squashing function, the sigmoid function. Squashing function, and after this we can apply some sigmoid function or maybe the ReLU function. ReLU is the maximum of 0 and x we can consider, and with the help of this I can get the output. So I can determine A11, I can determine. Similarly, I can determine other outputs A12, A13 like this I can determine. So like this, I can determine A11, A21, A31 like this I can determine. So this is a simple neural network. And we can apply some activation function like the softmax we can apply. So this is the sigmoid function. The training already I have explained the training concept. So we know the desired output. When we can calculate the actual output. The difference between these two is called the error. The error is back propagated to the input, and so that we can adjust the weights of the artificial neural network. So this is the training of the artificial neural network. So here I am showing one example. The inputs you can see, and corresponding to these inputs, the weights are 2.7, 8.6 like this. I can determine the x, and after this I can determine fx. Fx also I can determine. So how to do the training? I can show this example. So I have the classes. The output is for the class 0 and 1. Two classes we are considering. And I have the input. Input is, suppose one input is 1.4, 2.7 and 1.9. So I am giving this input. So first I have to initialize the random weights. The weights are random. And I am giving the input. Input is 1.4, 2.7, 1.9. Corresponding to this, the desired output is 0. Corresponding to this, the desired output is 0. But I am getting the output. I am getting the output 0.8. I am getting the output 0.8, but the desired output is 0. So I can determine the error. So what is the error? Error is 0.8 minus 0. So error is 0.8. 0.8 is the actual output, and 0 is the desired output. So this error is back propagated so that I can adjust the weights of the adjustment. So I am doing the adjustment of the weights. So the weights are adjusted so that I have to minimize the error. The weights are adjusted, so I have to minimize the error. After this, I am going to the second input. Suppose the input is 6.4, 2.1, 1.7. And what is the desired output? The desired output is 1, but actual output is 0.9. So error is minus 0.1. This error is back propagated to the input so that I can adjust the weights of the artificial neural network. So I have to do this. So if I do this, I can train the artificial neural networks. So this is the training of the artificial neural network. So like this, I have to do this repeatedly, and after this, I can do the training. And you can see the decision boundary perspective. So randomly, I can initialize the weights. And this is the decision boundary between the classes. Two classes we are considering. One is the blue, another one is the yellow. And like this, I have to adjust the weights, and you can see the decision boundary. The decision boundary is moving. And like finally, I am getting this decision boundary between the classes. So you are getting a non-linear decision boundary between the classes. The non-linear decision boundary. Okay. So with the help of this, with the help of these artificial neural networks, you can get the non-linear decision boundary because we are considering the sigmoid function. The sigmoid function is a non-linear function. So that is the advantage of the sigmoid function. So this concept already I have explained, the back propagation algorithm. So already I have explained, apply the input, determine the output. After this, I have to determine the error. After this, I have to minimize the error. So that is the errors are minimized. So this is called the back propagation training. And this is I have to adjust the weights. You can see I am determining the error. I have to minimize the error so that I am updating the weights. If you see the equation, I am updating the weights. So this is called the back propagation training. And sigmoid function is, the advantage is a non-linear function. So that means we are getting the non-linear decision boundary between the classes. And also it is easy to determine the derivative. Derivative can be easily computed for the sigmoid function. So that is the advantage. So this is the case. So fx is a nonlinear function. And with the help of the nonlinear function, we can consider or we can get the nonlinear decision boundary between the classes. So if the fx is linear, then in this case, I will be getting only the linear decision boundary between the classes. But fx is nonlinear, so that is why I am getting a nonlinear decision boundary between the classes. And if I consider a linear support vector machine, I will be getting linear decision boundary between the classes. So fx is linear, then I will be getting the linear decision boundary. Fx is non-linear, I will be getting a non-linear decision boundary between the classes. Okay, now. So I have these type of neural networks, MLP, the multi-layer perceptions, feedback networks, hope fill network, competitive networks, self-organizing networks. So these type of networks are available. So already I have discussed about the MLP, multi-layer feedback, and feedback or the recurrent networks are also available. Hope fill networks, I will show one by one. And this is one example of the MLP, the multi-layer perception. So multi-layer perceptron, this is one example. Input layers are available, hidden layers are available, and output layers are available. And you can see the interconnections between the neurons. So this is also the MLP, the multi-layer perceptron. So input layers, hidden layers, and the output layers. And you can see the interconnections. The feedback network is mainly the recurrent network. The output is fed back to the input layer. That is a feedback network. And hope fill network, you can see the each node is connected to every other node. So one is connected to 3, one is connected to 2, 2 is connected to 3. So all the nodes are connected. And you can see the symmetric weights. That means what is the meaning of the symmetric weight? From 1 to 3, the weight is -2. From 3 to 1, the weight is -2. So that is called a symmetric weight. From 3 to 2, the weight is 1. From 2 to 3, weight is 1. So this is called a symmetric weight. So this is called the hope fill network. And competitive learning is mainly used for the clustering, the grouping. So unsupervised learning. So this concept I am not going to explain. If you see, I will give the link of my video. In the YouTube, I have some videos. You can see what is the competitive learning. So mainly I am explaining the competitive learning can be used for unsupervised learning. So in my YouTube also you can get what is the competitive learning. So here I am not explaining the competitive learning, and also the concept of the self-organizing network. So in my YouTube video, it is available, the self-organizing map. So this is mainly for the unsupervised clustering. So different types of neural networks are available. So again, also I'm not explaining all the networks. So there are many advantages and disadvantages of the networks. So I'm not explaining all these networks. Now let us discuss about the deep learnings. So another 15-20 minutes I will explain, and after this I will explain some applications. So you can see the traditional pattern recognition system. So what we consider, suppose this is an input image, we extract some handcrafted features. Maybe the shift features. In image processing you can get the features, the hog features, the histogram of oriented gradients. We can consider the color information, we can consider the texture information, or we may consider some other information like grayscale intensity value. So this information we can extract from the input image, and after this we can apply the machine learning algorithms for classification. This is traditional machine learning, traditional pattern classification. But in the deep learning, what we can consider, we have to in the traditional case, what we are doing, first we are extracting the features, and after this we are doing the classification. First we are extracting the features, and after this we are doing the classification. So in the deep learning, what we are doing, deep learning is nothing but a cascade of nonlinear transformations. So we are considering the cascade of nonlinear transformation, and it is end-to-end learning. Why it is called a deep learning? Because I want to extract more and more information from the input image, from the input signal. So I can extract the low frequency information, I can consider the mid frequency information, I can determine the high frequency information. So all this information I can extract from the input image. So this is the hierarchical model we can consider, and it's an end-to-end learning. Okay, so that is why I am considering the cascade of nonlinear transformation, the deep learning techniques. So cascade of nonlinear transformations. So from the input image, I can extract all this information, the mid frequency, low frequency, all the information I can extract. So you can see the traditional machine learning and the deep learning. So in the traditional machine learning, first I can extract the features, feature extraction. After this, I can do the classification. But in the deep learning, what we can consider together, we can do the classification and the feature extraction. We can extract the features and we can do the classification together. And why it is called a deep? Because we are extracting more and more information from the input signal, from the input image. So it is nothing but the end-to-end learning. So here you can see corresponding to the deep learning, suppose input image is available. From the input image, I can extract the low-level information, the mid-level information, the high-level information. In case of the high-level information, in case of the image, this is nothing but the edges and the boundaries. The edges and the boundaries are the high frequency information. So all this information I can extract from the deep learning by using the deep learning techniques. So if I compare the deep learning versus machine learning, you can see the comparison. So accuracy in the case of the deep learning, it is very high as compared to machine learning. But the deep learning requires the large amount of data, training data. That is one problem. And training time is also very high in case of the deep learning. And in case of the deep learning, we need GPU. But in machine learning, we can consider only CPU. One CPU we can consider. And hyperparameter tuning. So there are many techniques for hyperparameter tuning in case of the deep learning. But machine learning has limited capabilities. So tuning capabilities. So that is the distinction between the deep learning versus machine learning. So again, I am showing the traditional machine learning techniques. Input image is available. We are extracting the features, handcrafted features. And after this, we can apply the machine learning algorithms, the support vector machine and all these things I can apply. So this is one example. Computer vision features, maybe shift feature, hog features, or maybe the texture information we can consider. The color histogram we can consider. Color shift we can consider. The texture information like LBP we can consider. So all these things we can consider for computer as a computer vision features. Again, I am showing this one. Already I have shown this one. And you can see if we have the huge number of training data is available, then you can see the performance of the deep learning is very high, very good as compared to traditional machine learning algorithms. It depends on the size of data. If we have the huge number of training data, then deep learning is obviously better than machine learning algorithms. So again, I am showing the supervised corresponding to this image recognition. We have to extract the handcrafted features, and after this we can apply the support vector machine or other classification techniques, and after this we can take a classification decision. So this is one supervised learning technique. And for deep learning, we can extract low-level features, the mid-level features, the high-level features, and after this we can consider the trainable classifier for decision making for classification. So all this information we can extract with the help of the deep learning techniques. Here also the same thing I am considering. The low-level features, the mid-level features, the high-level features we can extract with the help of the deep learning techniques. So like this, already I have explained this one. Now let us see how it works. So if I consider a simple artificial neural network, this is a simple artificial neural network we are considering. Okay. So input layers are available, hidden layers are available, and output is available. Okay. So already we discussed about the training techniques like the backpropagation training in artificial neural network. So we have to reduce the error. We have the desired output and what is the actual output. So from this, we can determine the error. The error is backpropagated to the input, and accordingly we can adjust the weights of the artificial neural network. So if I consider this simple artificial neural network, we can determine the response. A11 we can determine, A21 also we can determine that this response of the artificial neural network we can determine. Okay. Now number of parameters. Let us discuss about the number of parameters. How many parameters we need? So in this case you can see here we are considering 4 inputs and 4 nodes in the hidden layer, and also you can see one output layer, it is A12. So how many parameters if you consider the interconnections? 4 into 4, 4 into 4, 4 input nodes and a 4 hidden node, 4 into 4 plus 4 interconnections plus 1. So number of parameters are like this, 4 into 4 plus 4 plus 1. So for this network, this number of parameters we have to tune. But corresponding to this input image, suppose if I consider this input image, this is the color image. So I have to consider 3 components, R component, G component, and the blue component, red component, green component, and the blue component. And the size of the image is 400 into 400, and into 3 means the color image. So total input is X1 to X 480000. So this number of input terminals are available, and you can see the interconnections. We have the hidden layer, and corresponding to this, I will be getting the number of parameters. Approximately 230 billion parameters we have to train. That is very difficult to do in case of the artificial neural network. Very difficult to do. So if you consider this network, so many parameters we have to train. And if I consider only suppose 1000 interconnections, 480000 into 1000 only, then only I'll be getting approximately 480 million. That is also very big. We have to do the training. So 480 million parameters are available. So that is also very difficult to do. So what is the objective of the deep learning? Deep learning objective is, one objective is to reduce the number of parameters. In this case, the number of parameters in the artificial neural network is very, very high. So that is why we have to reduce the number of parameters. So here you can see simple neural network. Again, I am showing input nodes, four nodes in the hidden layer and 2 nodes in the output layer. So corresponding to this 4 plus 2, 6 neuron, not counting the inputs. So 3 into 4 plus 4 into 2, so 20 weights, plus 4 plus 2, 6 bias. So that is 26 learnable parameters. So many parameters we have to train. So now to reduce the number of parameters, we are considering the deep learning techniques. So one example is the convolution neural network, the CNN. So in convolution neural networks, we have the filters like this. So this is one filter. This is a high frequency filter. So with the help of this filter, I can extract high frequency information from the input image. So suppose these are the image pixels. I have to place the filter over the image. I have to place the filter over the image, and I have to do the convolution. Convolution means the multiplication and the sum up. So I have to consider all the pixels. Okay. Like this, I have to do the convolution. You can see the multiplication and sum up, and that marks I have to move from one pixel to another pixel. So for all the pixels of the images, I have to do this. Okay. Like this, I have to do this. So like this, in this case, if I do the convolution, then I'll be getting the convolved image. I'll be getting this one. So with the help of the convolution, I can reduce the number of parameters. And I'll be getting the feature map. This convolved image is nothing but the feature map. I'll be getting the feature map. So I can consider number of filters. So with the help of different filters, I'll be getting the feature map, different feature maps. So I'll be getting the convolved image. So with the help of the convolution, I can reduce the number of parameters because it is the multiplication and sum up. So you can see what actually the convolution. So here you can see this is the convolution. This is the filter W1, W2, W3, W4. These are the weights of the filter. And you can see I am doing the convolution. So I am considering this position A, B, E, F, this position. I am doing the convolution, and with the help of the convolution, this is the convolution. And I am getting the output. Output is H1. Similarly, I have to move the marks over the image like this. Again, I have to do the convolution. And corresponding to this, I am getting the value H2 like this. And like this, we have to do the convolution. So that means the number of parameters for one feature map is only 4. So only 4 parameters are available for one feature map. So I'll be getting a one feature map. The feature map is the convolved image. So for one convolved image, I need only 4 parameters. Only 4 parameters. So that is like this, I can reduce the number of parameters. And number of parameters for 100 feature map is only 4 into 100. 400. So like this, I can reduce the number of parameters with the help of this technique. So this is one example, that is the convolution neural networks. And another one is concept of the pooling. So with the help of pooling also, I can reduce the number of parameters. So there are 2 popular techniques. One is the max pooling, another one is the average pooling. So here you can see I am considering the input matrix. And if I consider the max pooling, in a rectangular neighborhood, I have to consider the maximum value. So if I consider the max pooling, so if I consider suppose the rectangular neighborhood, 2 by 2 neighborhood, so maximum value I have to determine. So 4, 1, 3, 4, 2. So what is the maximum value? The maximum value is 4. Similarly, 5, 3, 3, 1. The maximum value is 5. So 5 is considered. 3, 1, 1. So maximum value is 3. 1, 3, 4. So maximum value is 4. So like this, we have to determine the maximum value. So that is nothing but the sub-sampling. This is nothing but the sub-sampling. So with the help of this max pooling, I can reduce the number of parameters. And average pooling also, I can consider the average value in the neighborhood. So like this, this is the structure of the convolution neural network. So here you can see the input image is available. I have the filters. The filters you have shown, the 64, 64 like this. And I have the max pooling. The red one is the max pooling. Again, I am considering the convolution. So number of convolution layer and number of max pooling layer may be available. The number of many numbers, not only one numbers, maybe 2, 3, 4 like this. And after this, I am finally for the classification, I am considering one fully connected layers for classification. So I have number of max pooling layers. I have number of the filter layers. So convolution operation already I have shown. This is a convolution operation. So multiplication and sum up, you can see I am getting the convolve feature. That is a feature map I am getting. So convolution we have to do like this. Like this we are doing the convolution. Is a convolution. Like this we have to do the convolution. So here also convolution I am shown. So I have shown this is the high pass filter. So with the help of this filter, I can determine the lines, vertical lines. So I can determine the vertical lines. So with the help of this filter, we can determine the feature map. That is a convolve image I can determine. So these are some examples of the convolution filters to extract the features from the input image. So like this, we can do the convolutions. We can consider multiple filters and we can do the convolutions. And max pooling already I have shown. So we can consider the maximum value in a neighborhood, 2 by 2 we are considering. And stride is 2. Stride means the marks is moved over the image by 2 pixels. The marks is moved over the image by 2 pixels. So that is why stride is 1. If the marks is moved over the image by only 1 pixel, then the stride is 1. So with the help of the stride, also I can reduce the number of parameters. So how to reduce the number of parameters? By using the convolution, by considering the max pooling or the average pooling, or maybe considering the stride. The stride is 2, that means I am moving the marks over the image by 2 pixels. If the stride is 1, that means I am moving the marks over the image by only 1 pixel. So this is the pooling layer. Pooling means max pooling. So if I want to determine the eye detector like this, I have to do the max pooling. You can see first I am doing the convolution, and after this I am considering the max value, the maximum value I am considering. So like this, this is one example from the input image. I have to do the filtering. Filtering is convolution. After this, I am considering some activation function, ReLU function. And again, I am doing the convolution. I am doing the pooling like this. I have to do this. Convolution, pooling, I can do like this. So first stage, second stage, third stage, I can consider. And finally, for the classification, we are considering a fully connected layers. And suppose this example, I want to determine the beak detector, the beak of the bird. So only I need few number of parameters. So how to do this? So we can consider one filter, and maybe the upper left beak detector and the middle beak detector we can consider. And first I have to apply the filter, that is the beak detector. And with the help of the filter, I can extract the important information from the input image. So I can do the convolution with the filter 1 and the filter 2. And with the help of these filters, I can extract the important information from the input image. The 6 by 6 input image. And you can see, if I consider stride 1 means I am moving the filter over the image by only 1 pixel. So this is stride 1. And I am determining the dot product, that is the dot like this. The dot stride 1. This is for stride 1 and this is for stride 2. Stride 1. So first filter I am considering. So filter 1, it can determine the diagonal lines. So you can see along the diagonal line, the value is 3. Along the diagonal lines, it is 3. So that means it can determine the diagonal lines. So I will be getting the feature map. So like this, I will be getting the feature map. So for filter 2 also, I can do the convolution. For filter 3 also, I have to do the convolution like this. I have to do the convolutions like this. Filter 1, filter 2, filter 3 like this. So I have the feature maps. For the color image, I have 3 channels. One is the R channel, another one is the green channel, another one is the blue channel. Red, green, blue. So for 3 channels, I have to do the convolution. So I can consider filter 1, I can consider filter 2, filter 3 like this. And I have to do the convolutions and I'll be getting the feature maps. So like this convolution, I'll be doing. And finally, for the classification, I'll be getting the feature map. Okay, so I'll be getting the feature map. So these are fully connected networks. So after doing the convolution, I'll be having the feature map like this. So here you can see, so with the help of the convolutions, I can reduce the number of parameters. And finally, you can see I'm showing the connections. Only connect to 9 inputs, not the fully connected. So that means if you see that this one fully connected, so if I consider second one only connect to 9 inputs, so I can reduce the number of parameters. So if I connect like this, with the help of first I'm doing the convolution, and after this, if I consider the sharing of the weights are shared, then even I can reduce the number of parameters. So with the help of this, first one is the convolution. After this, the pooling may be the max pooling or the average pooling. And also by considering the concept of the stride, and also by considering the sharing the weights in the fully connected networks, I can reduce the number of parameters. That is the advantage. So like this, the whole CNN will be like this. First, the input image convolution I'm doing, max pooling, convolution, max pooling. After this 2D vector, this matrix is converted into vector. So it is converted into 1D vector. That is called the flattening. That means it is converted into 1D vector. And finally, for the classification, we are considering the fully connected network. And sharing of the weights, we are considering. So max pooling, the concept already I have shown. So the maximum value in a neighborhood we have to determine. So in this case, 2 by 2 neighborhood, the maximum value is 3. Here the maximum value is 0. Here the maximum value is 3. Here the maximum value is 0, 1. In this case, the maximum value is -1. Maximum value is 1. Maximum value is 0. Maximum value is 3. That we are considering. And the pooling, what is the advantage of the pooling? With the help of the pooling, we can reduce the number of parameters. That means I am doing the subsampling. So subsampling will not change the information. The subsampling will not change the object. So if you see the first image and the second image, the information is the bird. So that means the object is not changed. So subsampling do not change the object. Okay. So that means we need few parameters to characterize the image. We need only few parameters to characterize the image. So that is the advantage of the pooling. So that means we are considering the reducing the number of connections, sharing the weights, max pooling. Also we are considering to reduce the complexity. So max pooling we are considering like this. So I do not want to show here. This is the input image convolution, max pooling, like this. So complete CNN is this: input image convolution, max pooling. So number of convolution layers, number of max pooling layers. After this, I am considering the flattening. Flattening means this is converted into, the feature map is converted into 1D vector. And after this, I am considering the fully connected networks. So flattening is here. You can see the feature map is converted into 1D vector. So this is called the flattening. So this is from my book. This is the structure of the convolution. This is from my one figure. I copied from my book. And briefly, I will explain what is the concept of the autoencoder. So autoencoder is mainly, it is a artificial neural network. And in this case, I have the encoder. Another one is the decoder. So this is used for efficient representation of an image or data, efficient representation of input data. So it can be used for dimensionality reduction. Like the PCA can be used for dimensionality reduction. So in this case also it can be used for dimensionality reduction. So it has input layer like this. You can see it has input layer. That is the one is the encoder is there. After this I have the latent space representations. And after this the reconstructed image, that is the decoder. So here you can see in the input image, it is a noisy input image. And specularity is also there. Specularity means the mirror-like surface. That is not important. So autoencoder means it is the efficient representation of the input image. So input image is this. So we can extract the most important information of the input image. Noise is not important information. The specularity is not important information. So only the important information we are extracting, and that is the encoder we are doing. After this, I am getting the bottleneck layer. After this, I am reconstructing the input with the help of the decoder. So I am getting the output image, and here you can see the noise is removed the image is properly aligned, the specularity is removed. So that is why this is the advantage of the autoencoder. Efficient representation of the input image. So that can be used for dimensionality reduction. So like this, you can see this is the input image with a noise. The noise can be removed and we can generate the images. The face image, you can see the different faces we can generate with the help of the autoencoder. So it is an efficient representation of the input image. Here I can give another example. The noisy input image is available and we have the encoder and we have the decoders. So encoder means it is the efficient representation of the input data. That is the compressed representation, the latent space representation. And after this, from the compressed representation, I am considering the decoding. So with the help of the decoder, I can reconstruct this, and that is the denoise image. So in case of the autoencoder, I have the encoder, another one is the decoder. And here I am giving one example. Suppose these two sequence I am showing, first sequence and the second sequence. The first sequence is a very short sequence. The second sequence is a long sequence. So first sequence, it looks like first sequence is very easy to remember. But it is not true. The second sequence is very easy to remember. So how to remember the second sequence? The even numbers are followed by their half and odd numbers are followed by their triples plus 1. So if I know this rule, with the help of this rule, I can remember the second sequence. In the first sequence, it is not possible to remember. I can find the rules. So that is why the second sequence is easy to remember as compared to the first one. And that is the meaning of the internal representation of the input data, the efficient representation of the input data. So that is the meaning of this. So like this, in case of the chess player, the chess player can easily remember the pieces, the position of the pieces. So he knows the internal representation of the input data, and accordingly, he can reconstruct the output. So that is the efficient data representation. So I am not going to this. I will skip this one because time is not available. And also I am not explaining the concept of the adversarial network. So I will not again. So directly I will go to the computer vision applications. So one application is the gesture recognition. Gesture means the movement of the limb or the body as an expression of thought or feelings. So this is the definition from the Oxford Dictionary, but mainly it is the movement of the hand and other body parts. And this is a recognition. And human-computer interface using the gestures. So we can consider the human-computer interaction with the help of gestures. So we need not consider the mouse and the keyboard to interact with the computer. So with the help of the hand gestures, with the help of the body gestures, we can interact with the computer. Pointing gestures means with a robot, we can interact with a robot with the help of the pointing gestures. Even we can play the virtual games, or maybe from a distance we can communicate with a robot. We can communicate with a computer with the help of the gestures. So like this, there are two techniques. One is the data globes. So we have to wear the data globes. The data globes is connected with a computer. There is a cable, and whenever I move the fingers, I move the hand, the computer can recognize. The computer can recognize what I am doing. This is with the help of data globes. Another one is the vision-based system. The camera is available, one camera or maybe the multiple cameras. This camera can detect the movements of the hands, and accordingly there are some machine learning algorithms, the computer vision algorithms, the computer can recognize. So one is the vision-based system, another one is the globe-based system. So there are the comparison, the globe-based system and the vision-based system. I am not going to explain what are the advantages and disadvantages. So these are the vision-based interface. We can consider the hand tracking, hand gestures, arm gestures, hand tracking, gaze tracking, lip reading, facial expression, body tracking, activity analysis. Like this we can consider. And some of the gestures, suppose if I consider the hand gestures, static gestures are available. This is some American Sign Language. So computer can recognize these gestures. These are static gestures, and these are some dynamic gestures. The computer can recognize. Okay. So these are dynamic. These are used in the sign language. So the vision-based systems are available, audio systems are available, sensor-based systems are available, or the multimodal systems may be available. Or maybe the static gestures already I have shown. The dynamic gestures are available, and the isolated gestures and the continuous gestures. Continuous gesture means one gesture is performed continuously one after another. So that is very difficult, continuous gestures, because we are performing the gestures one by one. So what is the starting point and what is the ending point, the computer has to determine. Which one is the starting point of a particular gesture, which one is the ending point of a particular gesture, the computer has to determine. So there are many applications of the vision-based system, like human-computer interactions, virtual games, robotic navigations, robot interactions. So there are window menu activation systems, virtual surgery. So there are many applications of the vision-based gesture recognition systems. So there are many problems in image processing in computer vision, like segmentation, occlusion, illumination sense. So I'm not explaining all these things. In continuous gesture also, it is very difficult to do. Like if I perform the gestures one by one, I have to know which one is the starting point and which one is the closing point. And I have to remove the interconnected portion. One is first, I'm doing one, after this next 2, 3, like this I'm doing. So this intermediate part is not important. So I have to remove this one. So computer has to understand which one is not important. So this theory I'm not explaining. So I also different techniques for image-based systems and the video-based systems are available. Like we can consider the RGB model, the color models we can consider, and Gaussian models we can consider, GMM we can consider, like this we can consider. The hand models, like hand model, different types of hand models, like the texture models, the volumetric models, binary silhouette contour models we can consider. So these type of hand models we can consider for vision-based systems. And we can consider the features, some maybe computer vision features, or maybe the deep learning techniques also we can apply. So like the static gestures, you can consider the supervised k-means cluster, unsupervised k-means clustering, support vector machine, artificial neural networks we can consider, or maybe the hidden Markov model, HMM, artificial neural networks. The conditional random field, CRF is the conditional random field. So these type of techniques we can use, like this dynamic time warping, artificial neural networks, the hidden Markov models, conditional random fields. So these type of techniques we can use popularly. And some other techniques like the deep networks also we can use, the convolution neural networks. The recurrent neural network is very important. The LSTMs, so I have not discussed. So these techniques are used can be for gesture recognitions. So these actually we develop something, human computer interactions. You can see hand tracking, TV remote control by hand in our laboratory. And you can see 5 to it is the calculators. T is recognized. TV remote control by using gestures. And this is a calculator, some calculator type of things, 5 and 2. So these are some techniques. And also we develop some hand gesture animation systems. So we develop some animation systems, hand animation systems. And like hand animation systems also, we develop some systems for hearing impaired people, the Indian Sign Language systems. So this is under the Ministry of Human Resource and Development that time. So we developed this system, the Indian Sign Language Education and Recognition Systems, like this. And you can see these sign language systems. And we also developed some globes, the globes systems we have developed. We have designed the globes. So if we import this globe from USA, it is around 20 lakhs, 30 lakhs like this. But in our laboratory, we have developed some systems, the human-computer interface systems. And one is the vision-based system and one is the globe-based systems. So this is the complete system. So with this help of this, we can interact with the computers. My team, actually mainly last 15, 16 years, I have been working on this domain. So this interaction with the computers, with the help of the camera and the globe-based systems. So for this work, I was awarded the National Award for the Best Applied Research. So this is a National Award for the Best Applied Research, awarded by President of India, Government of India. And also my another research is during this facial expression recognitions, some of the expressions. So this is computer, how to recognize facial expressions. So different types of expressions. So if you see the face tracking and facial expressions we are considering. So one of my student, PhD student, he developed something like facial expression recognition, different types of facial expressions. And face recognition also we consider. And also the skin color based segmentation also we develop some techniques. So some color models we are considering. The skin color based segmentation. We develop some techniques. And the dynamic models also, we consider some dynamic models for skin segmentations. We publish some papers on dynamic segmentation like this. You can see the skin, based on the skin color segmentation, we are doing the segmentations. These are segmentation techniques. And we develop some like this, the eye detection, eye based in human computer interactive systems. And this is also the depth estimation from monocular image. And this is also another technique. We determine the depth from the monocular image. This is also from the depth information. We can determine the depth from a single image. So this type of the development we have done. You see the left image and the right image, we have done the motion amplification. So if I click here, have you seen any motion here? No. After this, we did motion amplification. You can see the movement. Small movements we can determine. Have you seen here in the first video? You cannot see, but in the second video you can see small motion is amplified. Similarly, in this case also, have you seen any small motion here in the first video? But in the second video, you can see we are amplifying small motion, the motion amplification. The small motion we can amplify. And also another one is the tracking of the soccer player, tracking of people for the video surveillance. We are doing the tracking. This is the third one. The fourth one is the multiple camera based tracking. This is the car number plate tracking, the car tracking. So these are some applications of computer visions. So we in our laboratory we developed this by students. So these are the car tracking. These are some people tracking, another soccer player tracking. The last one is the multiple camera based tracking. 2 cameras are available. You can see the 2 cameras are available and we are doing the tracking. And also we did some techniques for skin cancer detection. Also one of my students, he is doing on skin color segmentation, skin cancer detection, and the tumor detection in the endoscopic images and the endoscopic videos, and also the colonoscopic image and the colonoscopic videos. So detection of the malignant tumors, detection of the benign tumors, we are considering this one. So this is also one of the applications. So in our laboratory, we are doing this. My students are doing on this. So regarding this reference, actually, I'm from my book, I'm explaining some of the concepts. So this is a textbook. The textbooks on computer vision and image processing, published by CRC Press. If you see the reference number 4, that is the NPTEL course, video course. So it will be starting from 24th January. So if you want to enroll this course, then you have to go to a SWAYAM portal. SWAYAM portal is available, NPTEL. Then you can go to this course and you can enroll the course. So this is a 12 weeks course. 40 lectures will be available. 42 lectures are available. 12 weeks course is available. So computer vision and image processing, those who are interested in computer vision and image processing and the machine learning, so they can join in this course. So you have to go to the NPTEL website. The SWAYAM portal is available. So in the portal, you have to enroll. The course will be starting from 24th January, this January. So you can see all the videos, my videos. So it is 12 weeks course. So those who are interested, they can see this course. So this is my textbook on computer vision and image processing. So it is available also in the library, some of the libraries. So you can see this book also. So thank you. Thank you for your patience. Thank you. So if you have any questions, then you can interact with me. So now I am not sharing my slide. Hello.
Yes, sir. So, dear participants, if have you any query, please ask.
So if you have any questions, you can ask me, and I encourage you to see my NPTEL course. Just enroll the course and you can see all my videos. So your another course will be from the next July, and that will be on machine learning and the deep learning techniques, NPTEL course. So any questions in the chat box?
Yes, sir. Also, you can write your question in chat box.
Hello, sir.
Yes, please.
Sir, for any problem, how can we choose that we will go for the machine learning or deep learning?
No, it depends on the application. Suppose already I have explained, if you have huge number of training samples, then you can go for deep learning techniques. But if you have limited number of training samples and the problem is very simple, then you should go for machine learning techniques.
Okay, sir. Kindly share the PPT so that we refer it.
Is it okay? I have covered many things in 2 hours, deep learning and machine learning. Is it okay?
Yes, sir.
I think, sir, huge information are there. In a short time, so many things you have covered, sir. So many
Okay.
things, and I think it's a wonderful session, sir. And
Okay, thank you.
this full session is informative, sir. Each and every slide gives some information.
Okay, thank you.
Sir, is
And
it
also,
possible to share
sir,
PPT?
thank you for your kind information. There is the NPTEL course. You are the coordinator, I think, sir.
The NPTEL course, I am the faculty.
Faculty. Okay.
So NPTEL my course. So you can get my videos in the YouTube also.
Yes, sir.
But better to enroll that course from 24th January.
Sir, of course, I should try, sir, to join this course.
Okay, thank you. Thank you.
So,
Sir,
okay,
if possible, share the PPT, sir.
Okay, I will send the
Is it
PPT,
possible?
but all the things it is not possible because the PPT, it has 350, almost 350 slides. So it is around 70, 80 MBs, something like this. So I will reduce some of the slide and I will send to the organizer.
Okay, sir. Thank you, sir.
So this course is organized by NIT Manipur. So I visited Manipur once for a PhD defense.
Yes, sir. That is Pitam, I think, Pitam Das.
Yes.
Actually, sir, your number I got from this Pitam Das.
Okay.
Then I was communicate with you.
Okay, thank you.
Okay, sir. Thank you. Thank you very much, sir.
Thanks.
Namaste,
Okay.
sir.
Namaste. Thank you.
Thank you, sir.
So thank you all the participants. So tomorrow is our last day of faculty development program. So there is a 2 session. Session 1 from 10 to 12 and session 2 from 12 to 2 p.m. After that, we should conduct an exam. There is an online exam, and the maximum marks of this exam maybe 20 or 25, not more than that. And the time duration should be 1 hour. So maximum you can get the 1 hour. So within these 1 hour, you have to complete all these answer of these questions, and there is no negative mark. So now thank you to all the participants. So and once again in advance you are welcome for the next session, that is tomorrow sessions. We should start at 10 a.m. Thank you very much.
Thank you, sir.